Intelligence, sponsored by AICTE Training and Learning Academy and organized by Department of Computer Science and Engineering, KMEA Engineering College, Ernakulam. We are delighted to have with us today our esteemed resource person, Dr. Sumod Sundar, Associate Professor at Providence College of Engineering, Chenganur. Yesterday, Dr. Sundar delivered an insightful session on diabetic retinopathy classification using deep learning techniques, part 1. Today, we are privileged to continue with part 2 of this engaging and highly relevant topic. We are truly fortunate to have Dr. Sundar with us as his expertise and deep knowledge will enlighten us, open new perspectives in the field of medical imaging and AI. With great pleasure, let us extend a warm welcome to Dr. Sumod Sundar to begin today's first session. Welcome you, sir.
Right. Okay. Thank you, madam. So I think it's audible, right now?
Yes, sir.
And is it audible? Audible, right? Okay. So give me 1 second to load the contents. 1 second.
Okay, sir.
Right. We should start sharing the screen. I think only we are having 26 participants now. So yesterday might be, I think it's due to the working day, right? So working day today. Yesterday we have around 100 plus participants. So I think this will be our last session, and hopefully yesterday's session was useful for you, right? And let me start sharing the screen. So I will have this session in 3 phases today. The first phase, I will continue my session, what I have stopped yesterday. So yesterday I was discussing about lung cancer, right? And so that I will finish now. And second thing, I will show you the idea behind the retinal image diagnosis. So then I will show exactly I will show the PhD thesis PPT, what I have with me, because I have 5 to 6 work on that retinal imaging. And I will show what are the things we can do there. And third thing, I will show a hands-on on CNN. Okay, CNN, I will show a hands-on code, how it works, how the CNN works, and how we can code. I think we will be having different level of people are here. Someone are good in that, someone are expert, someone are beginners. So we'll be clearing all the doubts for them as well. And I will be giving some hands-on code. Then I will explain how to make the data set like that. So that way, so in the 3 phases, I will explain the contents to you. So dear participants, you are all with me, right? Please don't switch on and go somewhere, okay? So shall I start? Can you chat me like yesterday? Can you chat me like yesterday? Is that okay? You are all with me, right?
Yes, sir. Yes.
Yes, okay. So let me start sharing the screen. 1 second. Okay. So I hopefully yesterday's session was also beneficial to you, right? It made some informative ideas to you. Okay. Let me start sharing. 1 second. All right. So yesterday we were discussing about the input or the introductory part of AI in medical imaging, right? We have seen various techniques we could use there, and hopefully you could see my screen, right, and hear my voice. Okay. So then we switched to in the second phase we have seen how the lung cancer and radiological images can be done using deep learning. Various ideas we have seen. So today we'll be continuing for the first time. So let me start. So I have mentioned about 2 ideas, right? Then I have done radiomic features, right? This you have seen, right? And now I can discuss about this one. The fourth one is if you're working on lung cancer, you can go in this way as well. So you could see my screen as well. So I will discuss about the lung cancer class, the possibility of a lung cancer classification using multimodality. What do you mean multimodality? You have seen that different type of modalities are there, right? CT is there, MRI, ultrasound, X-ray, and as well as JPG is also there. Right? So now we can see what is multimodality. Multimodality means we can work on the same, multiple modalities at the same time. Like, so you can see that this is the technique we have tried out. So you can see that the multimodality data set is the input. So we are working on the lung data. Okay, multimodality data set is a lung data. And using that data set, we have performed a brisk-based analysis. Okay, brisk-based analysis means, you know, suppose imagine you are cutting an onion. Okay, you should be having multiple slices, right? You can see that. Imagine it's like a 3D image. So I 3D image, we can make it into different slices one by one, right? And you can see that the presence of that affected area will be the inner side of that slices, right? I mean, the top slices, it doesn't contain any affected area. So to find out that, see, for example, if I am cutting an MRI image into 1,000 slices, so that entire 1,000 slices is not needed to perform the classification, might be 500 or something. So we need to identify the affected slices might be residing at the inner part of that slices. So to find out that, we need to perform some sorting. So we have used a technique called brisk sorting. Brisk sorting in the sense, the intensity levels of the images are calculated. We have some equation I'm not showing you now. Please go to ChatGPT or something. You can find the equation. Brisk-based analysis will look like the will look for the intensity similarity calculation between the slices, and the top intensity based similar slices can be taken. So that is idea behind brisk. So once we select that top, for example, I have around imagine I have the data set I have made into 1,000 slices. That, see, this is a case of 3D image. Okay, so I have made into 3D 1,000 slices. So out of that I have selected 500 slices which are very relevant. So that will be containing the exact affected areas. But let it be 500 selected slices is taken from the brisk. Okay, so that 500 slices we have fed into a CNN model. Actually. We have fed into a CNN model. So today I will explain you, show you the hands-on part where the CNN, how we could use the CNN well. Right? So can you chat me how many have used the CNN? Yes or no? Have you tried out CNN as a hands-on part? Have you tried out the hands-on of CNN? Can you chat me yes or no? I want to know the response. Okay, please.
Yes, sir.
Right, right. Okay. If you are beginner, anyone from there? Yes. I think only 2 or 3 are chatting now, and the remaining participants are there, right? Right, right.
Yes, sir.
So, shall I show some hands-on as well for CNN today? It will be easier for you. Right, that's why I will give some scratch idea from the scratch. Okay. So you can see that this multimodality data set, we are made into various slices, and the top performing slices are taking, I mean, top ranking slices based on the similarity values, score provided by the Brisker technique, right? So that is fed into CNN, and that CNN will do the classification, right? As you know that, you can see that here, you could see that at the end of CNN, you will be having density, right? So we are having 3 type of classes: corpus cell carcinoma, small cell carcinoma, and adenocarcinoma. So 3 classes. For that, please note that at the end of the CNN model, we need to place 3 neurons. Those who have tried CNN, they know the concept, right? So this is idea behind that. Actually, we have that. So hope you got that. And another thing, what is a data set? So I have mentioned that we are working on multi-modality data set, right? So this is the data set what we have done. PET-CT and PET-CT small cell carcinoma. And so all these kind you can see here, right? I have told that we are having squamous cell carcinoma, small cell, that is SQC, this is SCC, and this is ADC. So that you can see here, right? PET-CT images are there and CT images are there. So it is a collection of images which is available in that data set, right? So this data set is actually a lung PET-CT DX data set, right? And how we could perform the brisk analysis. How we could perform the brisk analysis in the sense. So you can see that on we have tried on closed PET-CT scan images and non-cancerous affected image and open PET-CT and can. So we have looked into the brisk score of each and every. So based on the brisk score, the top performing brisk score indicates that the patterns are matching, so that are taken for training. Right? So these were the results we have obtained for each and so yesterday I have told that. So yesterday I have not shown any results. Today I am showing because this is the snip we have taken from my big paper, our paper. You can see that that top performing is lung PT, PET-CT DX is a data set we have tried out, and the modality was PET-CT image. So we couldn't mix up the data set because this is entirely different. I mean, we have taken CT images only and PET-CT images together. So at that time we can see that this much of images were there. 495 images for training, 522 and 523, and 72 for testing, and say totally this much of quantity of images were there. Right? So these are the ratio of the images which are taken for training and testing. So and you can see that we have performed this analysis, and one second, this was the results we have obtained at that time, right? So this was the result we have received at that time, and we got an accuracy precision recall which was higher, which was comparing to that data set, right? Another data set. And they have see lot of data sets were available when we tried that time. So you can see that some public data sets are there. So that is called, I mean, some data sets are launched by hospital, and this Han et al. Is a private data set. A private data set means they have collected directly from the hospital, which is not available for the public to download or use or experiment or something. You can see that, right? So this was the idea behind it, right? So this was the experimental results we have received. And how we could progress in lung cancer is that, see, we have mentioned about most of the works are focused on 2D concepts, right? 2D concepts. Now we can work around 3D. You could, I mean, if you're working, if you're proposing a plan on your research, I think I told that it's very difficult to getting a published a paper, especially in medical imaging nowadays. So I request everyone to do, I mean, those who are doing, you may please do like in 3D images, which is very challenging, like, because why it's become challenging is that, I mean, the tumor size is entirely different for different kind of slices, and the shape will be entirely different, and the presence of that affected area will be different in different area. And also, for example, if I am affected taking the first slide, so it will be in stage 1, right? And if I'm taking another slide, it will be stage 3. So the presence of see, the presence will be there, but the staging will be different for the different minutes. So that is a challenge. Mostly it is encoded. So so that's why I'm recommending that there is a scope in dealing with the 3D images for lung cancer detection. Right? And another one is augmentation techniques, right? So augmentation techniques, most of the concern is like all about not having enough data. So that time we should go for, hope you heard of your augmentation. Can you tell me what is, can you chat me? Does anyone tell me, can anyone tell me what is augmentation? Can anyone tell me what is augmentation? Can you chat me for voice? Can you give some voice like? Augmentation. What is the need of augmentation? You're all with me, right? Or have you switched on and leaving to someone, some other programs? You are with me, right? Can you chat me what is augmentation? I'm audible, right? Right. So augmentation is all about we are having if you are having less amount of data, we need to multiply it. I mean, we need to increase the size of the data set. That's why we can, yeah. Oh, so you're hearing, okay. So more data set effects. I mean, for example, there is a concept called a class imbalance issue. For example, I have 3 classes of data, adenocarcinoma, squamous cell carcinoma. So this is class 1, this is class 2, and it will be class 3. Imagine the class 1 is having 100 data, class 2 is having only 30 data, class 3 is having only 5 data, right? So you can see that if we are training the size, I mean, training the model or training the CNN based on this data set, it will be very biased, right? Bias in the sense it will be biased to one class. So that is the case when we train the data set with this data, it will more inclined to where this, I mean, the model will learn the class 1 data features more, right? The model will least learn the class 3. So this is not a good practice. So, I mean, we need to increase the data set where the class is less available. So that time we could go for the technical data augmentation, right? So that time we could go for data augmentation. So we could use the increase the technical augmentation. A lot of techniques are there. Slide rotating, stretching, flipping, that kind of horizontal stripping, that kind of techniques are there. But if I propose, I suggest you to do some GAN-based augmentation. GAN-based augmentation is very, it's feel like novel, and it's not simply novel, but if you are applying if you are not, instead of applying the simple traditional augmentation techniques, you could go for that kind of GAN-based augmentation techniques, right? So you could try that as well. And this is it. So anyway, I am winding up the session for lung cancer and radiological images using deep learning techniques. So we have seen the statistics part, all these things. The modality part we have seen. So based on nodules, we can intensity, we can classify the nodules. Based on location, we can classify the nodules. So various types based on subtypes, histological subtypes. Yes, small cell cancer, large cell cancer, carcinoma is there. Right. So we can do that. And based on TNF staging, more 3 shares are there, TNN and M. So based on the TNN and M, we can classify like this, right? So how to detect is like, this is the main challenge, right? So we have already seen all these things. So I have shown you 3-4 works we have done already, right? So I think I'm not claiming that you have studied all these things and we have covered the entire thing, right? So dear participants, you might be attended yesterday and today also. So hope you got an idea of lung cancer. Is that beneficial? Can you chat me? Yes or no? In the next phase, I'm going to the retinal part, retinal classification, and do some hands-on now. Right? Can you chat me? Is that okay? How it feels like? Hope you got any kind of idea. Lung cancer, was it beneficial? You're all with me, right? So that's why I'm waiting for a chats now. So can you chat me? Participants, I think around 50 participants are with us, but no one is responding. Yes. Okay. Okay. So I'm asking because to ensure you with me, because it's a working day, you need to attend classes or your house things, right? Yeah. Okay. So I think it's clear. So I'm winding up the first session for today. So now I can go to my PhD topics. I mean, what I have done in retinal imaging actually. So this is my retinal concepts, right? So that I will show you now, right? So I think we take 1 minute break. 1 minute break. You can take the eyes from your screen. 1 minute. Okay. Then I will start with my diabetic retinopathy conducts, what I have actually. So shall we start now again? Once again, shall we start? Can you share me yes or no?
Yes, sir.
Yes, sir. So yesterday we have seen the idea of A in medical imaging diagnosis. Today we are seeing yesterday again we have seen the lung cancer. I mean the third part, the retinal image diagnosis. Retinal image diagnosis means for my thesis work, actually, I worked on a concept called diabetic retinopathy and diabetic macular edema. These are two prevalent situations of blindness, actually. And always we say in research, we can say that diabetic or federation is saying that it is affecting 18 to 45. And we record computer aided diagnosis. And you can see in this picture, you can see that two kinds of affected areas, non-proliferative diabetic retinopathy and proliferative diabetic retinopathy, that I will explain now. So these are all two kinds of diabetic retinopathy situations. So this is the main idea of the data set or the task we are going to perform. So that I will show you the data sets and the website where we could take the data set. That I will show you, which is very easily available. And I think this can be given for. I mean, I'm not telling that this is not you please do PhD only, okay? But it can be given for your BTech or MTech projects for your students, right? So basically, for diabetic retinopathy, we are having these kind of 5 type of grades actually. So grade 0 is actually a non-apparent retinopathy, and grade 1 is actually non-proliferative diabetic retinopathy. And third one is grade 2. We can classify it as tell it as moderate NPDR. In grade 3, severe NPDR actually. In grade 4 is proliferative diabetic. And you can see the details of the features of the each kind of classes, right? You can see that. I will show you now. It's already there. And so no apparent retinopathy means this is one class. I mean, there is no abnormality. But in the case of NPDR, It's only microaneurysms that I will tell you what is microaneurysms. And see, this is which more less severe than, and this is more severe, and this is either a case of moderate or severe. So you could see that 5 classes are there. It's clear, right? Grade 0, grade 1, grade 2, grade 3, and grade 4 are there, right? Let it be there. And diabetic, and this is we have mentioned about diabetic retinopathy. And another case of disease is diabetic macular edema. So diabetic macular edema are of 3 classes actually. Grade 1, grade 2. I mean, 2 classes, one more class is there. You can see that 2 tasks are. So the main challenge of the diabetic retinopathy and diabetic macular edema is all about, see, one point is very important. The technical challenge is in capturing fundus images, because capturing fundus images is very tough because it requires some specialized hardware to capture or cameras to capture all these things, right? And another thing, see how the diabetic retinopathy happens is that the presence of that hemorrhages, the presence of hemorrhages, I mean, you can see that these are all the presence of hemorrhages. Sometimes the presence of hemorrhages are there. So that are irregular, like an amoeba shape. It is not like a circular or spherical shape. It's an irregular shapes like that. You can see that, right? And you can see, so the lesion are of different types, right? And the vessel means these vessels are of different pixels. So these are all very challenging in the case of W. And so what I have done is like, I have done a detection process for that detection process. And another thing, I have done some segmentation process. Then I have done some categorization, right? So I will show you what I have done for detection. In detection, I have, see, this is my area, what I have done. Okay, so for detection, I have used the transfer learning technique. Then for segmentation, I will mention this what are the techniques I have used there. And for classification, I have used the technique called a region proportional network and a variation autoencoder. Then I have used a gap convolution neural network, and then I have done wavelet CNN, right? So today I will show you how to do all these things, right? So 1, 2, 3, 4, 5, 5 tasks I have done using retinal inference, right? Okay. Slides not shown, right? Is that clear? Can everyone? I think I am showing the slide, right? Yeah, is my slide visible to you? Yes or no? Yes, right. You can see my screen. Visible. Okay. Okay, fine. So let it be the first task, second task, third task, fourth task, and fifth task, right? Can I show you that? Right. So you can see that. So what I have done is like, this is the done technique I have done, right? So for that, I have used the what do you mean by transfer learning? Can anyone chat me? What is transfer learning? What is that? So this is the first work. First work is all about diabetic retinopathy detection. Okay, diabetic retinopathy detection using transfer learning. So that was my first task. So can anyone chat me? What is diabetic retinopathy? I mean transfer learning. Can you chat me? I'm waiting for your chats. Can anyone tell me what is transfer learning? Anyone? So no one is there, right? Hope you are all hearing me, right? Hope you are all hearing me, right?
Yes, sir.
Yes, yes. So I think you don't know about transfer learning, right? Okay, okay. Fine, fine. So transfer learning means before explaining transfer learning, I should explain the concept of deep learning. But yesterday, yeah, yesterday someone told me that we know the concept of CNN, right? That's why I thought that we know the concept of CNN. So anyway, what I will tell, like, for example, a professor is teaching in a government college. Okay, a professor is teaching in a government college, and he retires by the age of 56. Okay, and after his retirement, I think you know that he has a lot of experience, right? So after his retirement, because he has seen a lot of students through his entire career. So after his retirement, some self-financing colleges or management colleges have invited him, and he has joined there as lecturer. So you know that most of the self-financing colleges can do that, right? Because they want their expertise of a senior professor like him. So imagine a professor is retired from a government college and is invited and taken as an HOD or principal to a new self-financing college. So what happens is that we are using the entire experience of that professor directly to a new environment, right? For a new task, for a new data set. New data set means the new task we are doing, right? So, I mean, the self-financing model is a new data set, right? So, for that, you can see that you can use the entire experience. But there is a challenge that, see, he is from, for example, he is from government college, okay? He is from government college, and after his retirement, that person X is taken to a self-financing college, okay? So after his retirement age, he is taken as HOD to a self-financing college. And we can see that we can directly use his experience. But the main problem, can anyone tell me the main problem? There is an issue behind that. Issue means we need to tackle for a few things. See, you know that this, for example, the person X is the data set, sorry, X is the person, and he is called a CNN, okay. The CNN is trained on the government data set. Government data set means they are having another set of data. For example, that data set is called a government data set, right? So that students and their attitude or their gate score or their plus 2 score is entirely different, right? I mean, sometimes it will be of higher quality. Let it be, okay. I'm not telling that self-financing are bad quality, okay. Let it be the entire domain and data set is entirely different, right? I mean, the features of the data set is entirely different. But that CNN is taken to a new data set here. Will it be a problem or does it create any problem? Can you tell me? Does it create any problem? It has some problem because you know that the professor is trained in a government college, but he need to face another data set, which is entirely different, right? So that time, the CNN might not work on this. I mean, the new self-financing data set, right? So hope you got my idea, right? The CNN is already trained on one data set, so the CNN can identify the entire features of that data set. But if you are using that CNN weights, we are taking the training and testing for the new set of domain. I mean the new data set. So does it have any problem or not? Does it have any problem? Yes or no? Does it have any problem? Because it is trained on one data set, which is having another set of features, but it is using on another data set. So this is a challenge of transfer learning. Hey, this is a challenge of transfer learning because you can see that this data set have different properties and this data set have another set of properties. So the transfer learning, by applying when we applying transfer learning, there is a technique called fine tuning. Fine tuning. So there is a technique called fine tuning. I mean, fine tuning in the sense, fine tuning. So what do you mean by fine tuning? Fine tuning. Fine tuning means we need to. So I think I can show you an example, right? I think so. I think most of them you don't know about transfer learning. I think you should know that, right? That's why I'm taking 2 minutes for you. 2 minutes for you. Is that okay? Can I take some time for that? I think transfer learning you should know, right? That's why you should be beneficial from my session. That's it. So here you can see that. Can you see my screen? Because the power has lost. Can you see my screen and audio? Because the power supply is lost here. Is it okay? Can you hear me? Can you even respond? Yes, okay. I think Wi-Fi is there, right? Okay, fine. So CNN is there, right? And CNN, for example, if I am taking for CNN, I am taking a concept called AICTE. Okay, I am taking AICTE. So you can see that AICTE having multiple layers. Okay, AICTE having multiple layers. So what we can do is like what I can do is like how to say that. So this is AICTE. This is AICTE. So this is AICTE, right? This is AICTE. So when we call the AICTE actually, we will be calling the weights of AICTE because which is already trained. Okay, the AICTE is already trained on another data set. Okay, the AICTE is trained on another data set, but it is not directly applicable, which cannot be directly applied on our data set. Okay, so what we do is like we call the AICTE and we will freeze that layers. We will freeze the layers. We will freeze the layers of AICTE. I mean, the top layers of AICTE, we will freeze. And we will add the new layer. For example, we will add new layer. we will add the dense layer. We will add the dense layer. Okay. We will add the dense layer to it. So then we will train. For example, AICTE is already trained. You can see that the AICTE is already trained on dataset 1. What we have is dataset 2. So I will repeat again. Point number 1. The AICTE is already pre-trained on the dataset D1. Point number 2, we will be just calling that AICTE. So that will load the entire layers of AICTE into here. But we couldn't apply the AICTE layer directly. So then what we do is like, we will freeze the top after calling the AICTE. We will be freeze the top layers of AICTE. And point number 3, we will add some add-on layers. Add-on layers, for example, dense layers we are adding. So now we can see that how much layers it contains. The entire layers of AICTE plus the newly added layers, right? So after having this entire model, what we do is like we will train that entire layers using D2. Entire layers using D2. Now you can see a magic that I have already told that the top layers of the AICTE is frozen, right? I have freezed all the layers of AICTE. So these 3 new layers will be trained with the D2. Okay, now we will generate a new set of weight called the W2. And I have already said that AICTE is already having W1. So the final set of weights will be W1 plus W2. I mean, W1 is additive with the W2. So that will be the new weight. So this is a concept of transfer learning. So hope you got that idea. Okay, can you chat me yes or no? So I will summarize in 3 lines. Simply, we will call a already pre-trained model, say AICTE, we will call that. So that entire layers will be taken. And the top layers of the AICTE will be frozen, right? And what the next point is like, we will be add some additive layers and that layers will be trained within the new data set. So already pre-trained AICTE having some weights W1 and that is not trained again because it is frozen, right? Then the new layers weight is W2. So the new layers will be updated with the previous layers. So that is W1 is added with the W2. So that will be the new weights and that weight is taken. So that is concept called as fine tuning. So can everyone chat me? Is that clear? The idea of fine tuning. I think around 50 participants are there. Okay. Can you chat me? Yes or no? Hope you got what is fine tuning. Hope you got that, right? Anyway, I'm skipping, so I'm removing all this, right? Okay. Anyway, so you can see that what I have done is like for my PhD, what I have done is like so the data set is taken and I have used the inception net. Okay, I have used the inception. So that data set I am fed into inception, and at the end of inception, I have added an SVM. Okay, at the end of inception, I have added an SVM. So I have tried out various models for that. You can see that see how this much of data I have taken, right? So it is having class imbalance issue. I have mitigated the issue of class imbalance issue, right? Then you can see that this was the result I have obtained. So AICTE I have tried along with the logistic regression, naive-Bayes, CART algorithm, SVM I have tried out. BGGNet along with the logistic regression plus naive-Bayes, CART and SVM, inception plus all this, all this. So for that I have obtained inception plus SVM has obtained the top performance, right? So this was the first work I have done there, right? So this is the binary classification only I have done. So my dear participants, I think it's clear too, right? Right? Yes, I think it's clear. So I think I can move to the next part, right? So I have tried out all these experiments. I have compared some values, right? And I have tried some real-time data set also. I have tried out some real-time data set which I have collected from my lab from the from nearby place Kollam. Okay, I have collected from there. And another work is all about segmentation. I have done some segmentation on that, right? Okay. So I think I can move the segmentation. Can you listen from here now? Can you take some breath and can you hear me? So I think it's clear too, right? So this was my proposal actually. So this was my proposal in the sense, initially we have performed a task called a classification. And that was a binary classification. I mean, the presence is yes or no. I mean, whether it is present or absent, right? And now I have used the technique called the unit, okay. And dear participants, you can search the website of unit. So I will show you where you can take the unit, right? Where you can take the unit, you can see here. You can see that. So you can take the concept of unit from here. Okay. Unit based paper you can. Okay. Unit based paper you can take. So unit based, this is the base paper of unit actually. So this is a good paper which is freely available to read. Okay, this is published in RK. So this is the unit based paper. I think it's in 2015. I remember that. Okay, 2015. Yes, 2015 is there. Okay, and this is architecture of unit. This is architecture of unit. You can see that. This is architecture of unit. So initially I have implemented this one, tried out this one. I see you can try using deep learning, which is using keras and TensorFlow. You can try it out. And there is another pipeline called, another framework called PyTorch is there. Okay, don't need to go for MX or something. You can use either keras, TensorFlow or PyTorch. Okay. You can try that. Try like that. Okay. So this is architecture, and you can see that it consists of various layers. So, but before explaining this, you should know about the concept of convolution neural network. Actually, okay. So I believe that you know the concept of convolution neural network, right? So if you are not aware about the convolution neural network, please read that. Okay, it is having multiple layers. You can add like that. Right? So here you can see that this is one convolution layer. Here you can see that it is indicated in the arrow mark, right? So this is a convolution layer, and two convolution layers are used here. And there's a technique called downsampling. Downsampling. We can say reduce the size of that output we have generated from the previous layers. So you can see that by downsampling, there's a technique called I have performed max pooling. Not I have performed, unit has performed max pooling. So hope you know about CNN, right? Only if you're aware about CNN only, you will get know what I am telling now, right? So then we have performed max pooling. Then again, two convolution layers are there. You can see that two convolution layers are there. So again, downsampling, downsampling, downsampling. So this will be the base part, right? You can see here. So here we will get a layer of 1 ton with the neuron size 1024. You can see here, right? And along with that, parallel you can do like that. So output you are downsampling, downsampling, downsampling to here. But on the other side, you can directly take it from the output taken from here, and it can be concatenated. It can be concatenated from the output from here actually. So it can be concatenated from the output from here, and this can be sampled together, and you can produce a segmentation map actually. You can see that, right? So at the end, so this will be concatenated. So they see this output and this output can be. So this is the architecture of the unit. And so what I have done is I have modified the unit actually, and which is made custom for the reference one, right? You can see that this is the model I have proposed. I have modified the unit for the because this is the traditional unit is all about only for the biomedical image. Microscopic image, but it doesn't work well for diabetic retinopathy images. So you could see that we can modify for our own data set. But for that only, there's a concept called apart from the classification, you need a concept called ground truth. Right? Yesterday I have already told that ground truth or mask we should have. Okay, ground truth should be there. Ground truth is ground truth. Ground truth is right. Ground truth. Using the mask, we need to we can locate. For example, I have 81 images of microluminescent class, 81 sample of soft X-ray. 81. So along with that, I should have the mask associated with each 81 images, the mask associated with each 40 images. So similarly, for each and every image, we should have mask that is called ground truth. So for we have only ground, if we have the ground truth only, so that we could perform segmentation. So we can analyze based on the measures like dice coefficient, U kappa, and area under precision. So AUPR graph and the score you could. There is a concept called ROC curve. Okay, ROC curve. By drawing the AUPR curve, you can take the AUPR score from that. Like you can take that. Okay. So this was the result I have obtained. So this is the segmented area. The vessel segmentation we have performed, right? So that is the idea behind that. The two tasks we have seen, one is detection and the second one is vessel segmentation. So is that okay? Right. So is that clear to you? I think I am running in the right phase, right? Is that okay? I want to show the hands-on code as well. That's why I'm running. Is that okay? Can you follow me? Yes or no? Yes, sir. So can I take a few seconds break to take some water? Okay. You also take some break for having you are taking the eyes from your screen. Right. So two techniques we have seen, one is for detection, another one is classification. And this is also classification, but this time I have used the technique. This is the proposed architecture, what I have, like this one, fundus images. So do you need my purpose actually? Do you need my purpose? Do you need my purpose actually? I will share my links in the group actually so that you can read it more. So I'm not telling that this is the best, but okay. Just I'm sharing my experience only. Lot of diabetic retinopathy are happening around and the papers are there. Okay. So you can see that the fundus images are taken. The ROEs are extracted. Okay. The ROE are extracted. In the cancer, what we have said yesterday is all about, we have extracted the ROEs, right? The ROEs are extracted and the feature extracted. So this is the modification I have done initially. For the feature extraction phase, I have used the variation autoencoder. Okay. So what is variation autoencoder? Does anyone know? Variation autoencoder. Variation autoencoder. Variation autoencoder. So this is also a kind of CNN. We could extract the data features, but what various autoencoder does is that it will extract the mean vector as well as the standard deviation vector, and it will be making it as an array combined together. That is called a latent space vector. So it contains the mean properties and the standard deviation properties, which require additional mathematics to need to explain what is various autoencoder in detail. Right? So after extracting the this array from this various autoencoder, that array, I mean the feature set. So you know that this is a feature set we are extracting in the form of a 1D array. So that is taken from the various autoencoder and that is taken to another cluster called the softmax progression. So there I have used 5 classes for diabetic retinopathy and 3 classes for diabetic vascular edema that I have taken from class. Right. So this is what I have done for that. So for ROE, I have implemented 2 techniques. One is selective search and another one is selective search and exhaustive search. So selective search which was found better. So that's why I have used that. So please go through that chat GPT. And once I extract the pictures, I have already told you, right? I'm not going to the flow. If you are doing some research, you can use this one TSNE plot. Okay. So that we got a latent vector space representation. What we explain is like, initially you have a data set and you will be having multiple classes, like 5 classes or 3 classes. So to ensure the class separability, to ensure that the class separability between the classes, you could use the TSNE plot. TSNE plot is there. So by plotting the TSNE plot, you can see that, whether it is clustered together. If it is clustered separate, I mean it has some differences or space between them, we can say that this is a enough class separability property, right? So we can try that. So that is ideal behavior for TSNE. So that will ensure to perform the classification the right way. So I have tried out the experiment on a clinical data set. So I think I have explained my 3 ways. One is detection, the second one is segmentation of vessel lesion, and the third one is all about again a classification. So this one I have used the graph convolution neural network, graph convolution neural. So can anyone tell me have you heard about graph convolution? Can you chat me? Yes or no? Graph convolution. Graph convolution neural network. Can anyone tell? Can you chat me? Does anyone know about the concept of graph convolution? GCN, graph convolution neural network. I'm waiting for it. No, okay. So this is that's kind of graph neural network, right? I mean neural network. So I have implemented that. I have tried out that. So what is advantage of graph convolution neural network? It extracts the topological features. Okay. Topological features means, for example, we can represent the data as a form of a graph. You know that a graph is a collection of nodes, right? A graph is a collection of nodes which is connected together, right? Which is connected by edges, like it is connected by edges. It is connected by edges, right? It is connected. So you can see that this is ensured by the connections. This is ensured by the connection. So the node can ensure the pixel. For example, we have an image. The image is divided into various parts. It may contain pixels, right? So these pixels can be represented as a node, and the adjacent nodes or the adjacent pixels can be pixel areas can be connected by using edges. And those don't having any connections between the nodes means they are not adjacent. For example, 2 pixels are in different places. 2 pixels are in different places. If I want to connect them, there is no connection between them. Okay, there is no connection between them, but the adjacents are connected like this. Adjacent are connected, right? If there is no pixel connection in between them, means they are entirely different. So we are looking into the topological features. I mean, the pixel that share the adjacent pixel value, which is neighbor. But in the traditional machine learning algorithms, they have the adjacent pixel estimation for all these things, right? So that we can use the traditional, even before the machine learning techniques, we can use the traditional image processing techniques, right? Using the traditional image processing techniques, we can extract the pixel hood information. So as an advanced way, we could use the graph neural networks, right? So graph neural networks are of various types. Graph neural networks are of various types. Graph convolutional neural network is there. Graph autoencoder is there. Graph LSTM is there. Graph RNN is there. So a lot of networks are there, right? So one of kind of network is the graph convolutional network. I'm not getting into deeper for that because you should know the basics of CNN so that only you should get all these things, right? So this is a technique I have used there. The input fundus images, ROE I am extracted. And again, I have extracted all these features and that features I am represented as a graph actually. So that I have done using PyTorch. So that I have represented as a graph representation. And that graph representation, this array, initially I have taken as an array representation. The array representation taken from this layer, I have concatenated, okay. I have concatenated, I have combined here for it. So that combined graph kind of representation is taken for classification. So before that, you should know how a graph neural network is implemented using PyTorch. Okay. If you know, if you have the knowledge on implementation of graph neural network only, it will be able to, I mean, you need to classify it. You are able to classify it, right? So for that, I have made into a graph kind of data set. So this I am summarizing. So initially I have collected the ROE, I mean images. I have extracted the ROEs. Then I have extracted the features, both using variation autoencoder as well as the graph convolution autoencoder. So might be few of them will be wondering that why I am repeatedly using variation autoencoder for feature extraction and GCN, right? So might be a confusion. But initially I have tried out GCN directly, but it is very complex at that time because it is very complex and very challenging and it is very difficult to process because the features will be missing. It is very complex again and again. So that time I have used the variation autoencoder, right? So that time I have used this one and then I have combined together as a graph neural network, right? So then finally I have made it for classification. Hope you got an idea. Dear participants, can at least 2 or 3 can you chat me? Is it clear to you what I have done? Hope you got at least 1 or 2. Hope you got an idea of graph neural network. I don't know that. I am clear that you are all not clear with the graph neural network, but hope you got some insights, right? Have you got some insights? So graph neural network is arrangement of data based on node connections, right? So I think I have represented that image using a graph neural network. So this was the idea behind that. So the final one, so that we can establish using confusion metric, evaluating using confusion metric. And the last one, I have tried using a wavelet CNN. So dear participants, can anyone know wavelet CNN? Wavelet CNN. Can you chat me wavelet CNN? Can you chat me wavelet CNN? No, right? So only one Professor Nessi is yes, yes. Professor Suraj, no. Surajit, no, the wavelet CNN. Sheena is not telling. Okay. He's telling that I don't know. Yeah, there's another concept called wavelet CNN. See, various types of CNN are there. So wavelet CNN works are very limited actually. So wavelet CNN actually do is like, so what I am exposing my PhD topic to is because some of them can take or can try out this thing in your data set, right? Might be I couldn't guarantee that you will get some good results. Okay. So this wavelet CNN differs in architecture also. So how it differs is like in between layers you are extracting the array and you will be concatenating in between. So I need to get into the mathematics degree. So please read that. Okay, if you are interested, you can try that. And because we are extracting the low frequency components and the high frequency components as separate metrics. So you can search the wavelet CNN base paper also. Okay. So that in base paper, they are showing the entire architecture and actually they tell how the high frequency and low frequency component of an image can be taken, right? So that I have performed. And the end, you will be see every CNN architecture, we can modify. Okay, we can modify in the sense you know that the CNN architecture consists of multiple layers. Most of the CNN architecture ends with a dense layer. Okay. So might be every CNN architecture ends with a dense net. So for example, imagine a CNN with a dense layer with a neuron 2. So that dense layer we can avoid, we can dense layer. So before the dense layer, here, what I'm indicating the green color. Before that, we can collect the features. You can, for example, if I'm print the features, I mean, print a variable. After this layer means we can extract the features. So that we can feed into another decision tree or SPM or ML classifier, base or an extractor classifier. So that I have done, right? The features expected from the wavelet CNN. I mean, we got a separate matrix or an array. So that is the big issue. So based on that, I have taken some results. So please read more on wavelet CNN, right? So what I have done this way. So then wavelet CNN I have tried with XGBoost. I have tried with random forest wavelet CNN with CNN. Right? So what I have presented before you is my PhD work actually, right? So then I combined with a few techniques and all this. So here, what we have seen is like we have seen some transfer learning technique, the segmentation of threat unit and regional proportional network. So we have done some classification. So, so dear participants, I have quickly gone through what are the techniques or which are the practices we can do, even though in written images or any kind of images. So, for example, point number one, if you're trying on JPG or PNG or images, it will be very easy to process. It is the very easiest way to do all this. And another kind of modality is CT, which is a little bit challenging. Okay, X-ray is very good. Actually. I mean, X-ray is a little bit good actually. I mean, it's easier comparing with CT and MRI. And so, point number one, I have mentioned about JPG images. Then X-ray is also good, but processing CT, especially MRI, especially 3D MRI, is very difficult to do. So because it may contain 3D volumetric data for slices of data. Right? Is that okay? So that way it is very challenging in the cases of different kind of models. So dear participant, I think I got an idea. I shared some ideas with you. So this is my second phase of my session today. So next I will show you where we could take the data set and how to perform some hands-on. So on the next phase, on the next 30 minutes, I will show you which are the data sets what we can take publicly and how we can perform the CNN. Is that okay? So that will be our agenda for the third session, I mean for the next 30. So dear participants, is that okay? Can you follow me? You hope you are listening, right? Listening, right? Can you chat me? I will tell you how to do that, and I will tell you how to code the CNN part. Right? Is that okay? Can you follow me? Yes or no? Can you chat me? Or the next 30 minutes, I will show you. So I think it's 3 p.m. So I think can we take a 5 minutes break? Then we will quickly do all this answer. So I think I can take some water from outside and join in 5 minutes. Okay, thank you. Madam, Vidya Madam, we can take a 5 minutes break.
Okay, sir.
Okay, okay.
Income tax department, but income tax revenue. എന്ത് പോയാ എ ഗ്രേഡ് കിട്ടിയിട്ട് ടൈം എന്തിനാ ഒരു ഗ്രേഡ് കിട്ടില്ല നീ പറഞ്ഞത്
So, dear participants, can we start that? So, hope you have joined, right? So we can start in 1 minute.
So shall I continue?
Yes, I think we can start, right? Okay. So, dear participants, once again, welcome back. I think this will be the last session of your FDP. I think this is the last session, I think, right? Finally. So, we can move to the data set part, right? So, that is, you can see this site, okay? grandchallenge.org. Okay. So, the grandchallenge.org, it contains a lot of open competitions which is readily available. I mean, some of them are easily downloadable. Some of them you need to enroll into the competition so that only it will be available to download, right? So some competitions are available with their platform as well. I mean, you can run the data set with their own website and you can take some result. So you can see that CT. So some works you can take on for your research as well. Okay, you can see that CT, MRI images are there. So all these kind of. So what I am showing you is like you can say Google like HYDRID. Okay, HYDRID challenge. Okay, HYDRID challenge. So HYDRID challenge diabetic retinopathy. You can see that this is a website for HYDRID claims. So this is one of the easiest website you could take for that. 1 second, 1 second. ഇത് 3 ദിവസം അവർക്ക് ഓണം സെലിബ്രേറ്റ് ആ 3 So you can see that diabetic retinopathy. This is a website for, and when you are logging into that, you can see that it will. We need to sign in. Actually. That's why I'm showing you. Some of the website is actually if we are not getting the data set directly because we need to enroll in the program and we need to enroll in the challenge and we need to get that. Once the challenge is expired, the data set will not be taken. But you can here you can see that even though the the challenge is over, we could log in and into the data set and into the website and simply you can log in. Okay, simply you could log in using your Google website. Okay, through your Gmail ID, you could extract that. Okay, you could extract that, and you could say that here you could see the challenges of the and you can see the challenges is like a lot of challenges are there. So let me go into the ITRIP data. I have missed out. I did grand challenges. Okay, you can see that this is sub challenge one. Sub challenge one is actually is all about lesion segmentation. If you are a beginner, you can start from here for segmentation, lesion segmentation, lesion segmentation. So you can see that you can extract the vessel lesions actually. So here you can see that the presence of microaneurysms are there, hemorrhages are there, and soft exudates and hard exudates are there. Right? So you can see that only less amount of images are there because we record only less number of masks only there, right? So you can see that. And sub-challenge 1 is all about lesion segmentation. Sub-challenge 3, sub-challenge 3, you can see that. Sub-challenge 3 is all about optic disc and fovea detection. You can see that the presence of optic disc and fovea detection is there. So if you want to try or if you make your students to do some projects, you can try from here. OD localization or OD segmentation, right? We can see that. Okay. And the third challenge, I mean, sub-challenge 2, this is classification where simply you could try from here. This is all about classification. So 5 type of classes, I have already mentioned that, right? Grade 0, grade 1, grade 2, and grade 3, and grade 4. Right? So these are all the 5 classes actually you need to do that. Then you can see that here you could see that I have already mentioned that initially in my PPT, I have mentioned the severity of 5 classes. Grade 0 is there, grade 1 is there, grade 2 is there, grade 3 is there, grade 4 is there, right? And also diabetic macular edema, it consists of 3 classes, right? So see, in the PPT, I have shown only a few data sets. But during my PhD time, I have done 5 to 6 data sets, I have tried the experiments there, right? And finally, only I have came to hydrogen data set, then only I got the clinical data. I have tried on multiple data sets, which is publicly available, okay? So that I will tell you now. So this was the data set, okay? So these images are readily available. So if you are a beginner, you can try this data set, right? So another data set also there. I just forgot the names. Data sets for retinal images from, okay, or diabetic DR fund of image. DR fund of image. DR fund of image. I will show you know. Retinal image data set. I just mentioned in the my literature review, I have mentioned all these things. Can I go to the chat GPT and just show you because I have the names now. 1 second. Okay, that I will recommend you few data sets. So any beginner can try from there. Here you can see that. Let me take this. Yeah, IPACS dataset. You may note it down. IPACS dataset is a very good dataset. Aptos is another dataset. IPACS is a very good dataset because it contains lot of high resolution images. I have worked on that. Both IPACS, Aptos, I have tried out. I have done that. Then IDRID, we have seen now. IDRID dataset. Mesidor and Mesidor 2 is E of the is a dataset. STARE is a very good dataset because it contains, I think the images are of good quality on STARE. Okay. The drive is not up to a good quality. I have tried out that, but I don't know ROC and HRF. I'm hearing it for the first time. So I recommend these dataset, IPACS dataset, Aptos dataset, IDRID dataset, then Mesidor, both Mesidor dataset, the STARE dataset as well. EFTA is not bad, but drive is not up to a good quality. So I recommend all these dataset. I don't know. Okay, I'm hearing it for the first time. Some of them are publicly or private dataset which is collected from the hospital, right? So I recommend few datasets for you, but because I have tried that. So is that okay? Can you note it down? IPACS, Aptos, IDRID dataset, Mesidor dataset, that drive STARE dataset, STARE dataset. Dear participants, you are following me, right? Can I take your chats? Right. Okay, I think it's clear. So shall I move to the implementation part quickly? So when I take the workshop on CNN, I will go through each and every layers and then I will show you the implementation. Today I will go through the glimpse what we can implement, how you can do that, right? So can I take the CNN part? CNN, right? This is the idea of CNN, right? Idea. You know the concept of DNN, right? I'm not going to DNN because we don't have time, only 50 minutes left for us, right? So shall I show the CNN part? How to do the hands-on? Let me take that. So CNN are of different type. Okay. AICTE is there, VGGNet is there, RusNet is there, InceptionNet is there, even VGG16, VGG30, VG252, lot of VGG networks are. RusNet also. Can I show you some site like, you please take a look at that later. KRAS, okay, KRAS. I remember it is KRAS models. You can write like KRAS models. This is not model from the film industry. Okay, I will show you like KRAS. Oh, this is Kerala models. Right? It will be KRAS models. Okay, KRAS models. Yeah, this one. Models API. Okay, models API. KRAS models. Let me take where it is like I forgot. KRAS applications. Okay. In KRAS applications, you can see that multiple models are there. You can see if you're a beginner or if you're a practitioner, you go to this site actually, this KRAS applications. You can see that exception range is 16, 19, see, load of networks are there. So if you're a beginner, you can try some YouTube videos, but you can click on that exception. You can see that how it can be implemented. So hope you remember what I have mentioned about transfer learning, right? Hope you remember transfer learning, right? So transfer learning is simply calling that function and placing that layers and add few layers and train the new layers on a new data set, on our data set. So that is the idea behind transfer learning and fine tuning, right? So is that okay? So here, what in that website already they have told that how to do that, okay? So initially, I think they have modified the website to some extent. Like initially, it was there to yeah to how to call them actually, how to call them, how to call them actually. Okay. So you need to go through you can go through all these things, right? So how to implement all these things. So this I have mentioned only. So this is the concept behind transfer learning. But what I am showing you is like this is a CNN model, what we can design from the scratch. So if you have a custom CNN model or a CNN model can need to be designed from Europe, and let it be a model called the convenient. Okay. For example, an input image. Please listen from here. If you are a beginner in practicing or experimenting or doing the coding, it will be helpful for you. 28 into 28 into 1. So let it be that input image. Then that is fed into the convolution layer. Okay, convolution layer. I think. So in convolution layer, it is having multiple layers. So I know that it is very difficult to teach you the idea way. So do anyone know the concept of CNN? I will show you like CNN is here, right? CNN. CNN means it is having multiple layers like that, right? So let it be like this. Okay, convolution layer, relative layer, and pooling layer. Lot of operations are happening in convolution layer. Some operations are happening in relative layer. Some operations are happening in pooling layer. Dear participants, I am in a belief that you know CNN, or else you will go to CNN, but not a workshop of CNN only. If it is a workshop for CNN or an FDP or a CNN, I will teach you each and every layers and the max behind each and every layers. Simply, I have some such thing so that I will show you one by one, and that you will get an idea of CNN, right? But simply, you believe that CNN consists of multiple layers: convolution layer, relative layer, and pooling layer, and that we can add again and again and again. So that then we will be getting a dense layer like that. So at the dense layer, we'll decide how to detect that one, right? So you can see that, for example, this is not up for you. Here you can see that for a convenant, you can see that let it be first convolution layer. Okay. This is first convolution layer, and followed by we need to add a relief layer. You can see that relief layer. So you can see that relief layer, and followed by that you can see that this is a convolution layer. Followed by there is a relief layer, right? For a relief activation function, you can call. And followed that, you can see that a max pooling layer is there, right? Max pooling layer is there. Then followed that, it is followed by a dropout layer. See, I'm not going to explain all these things technically in detail. Please go try it again. There is special purpose for having this max pooling layer, dropout layer. There is some strict reasons behind that. Okay, there is some strict purpose behind that, right? Then we need to flatten it, right? Then we need to perform a dense layer. A dense layer means it is the arrangement of a layer with the 128 neurons. Okay, 128 neurons. Then finally dropout layer. Dropout layer means we need to simply deactivate some of the neurons. So that is the dropout layer. So dropout 0.25 means 25% of the neurons in the previous layer should be deactivated. So that the overfitting. Okay, what about overfitting? Do you know overfitting? Without overtraining a model, we can prevent, right? So that is done by using dropping. At the end of the layer, we should have this is very critical. This is very critical. The number of neurons in the final layer is very important. Number of neurons. Can anyone tell me? Can you tell me how to decide the number of neurons in the final layer? Number of neurons in the final layer. Number of neurons. Oh, so anyone know CNN? So the number of neurons in. So if you want the CNN, you please call me sometime again after. Okay. Yes. If you know CNN, it's fine. Based on the number of classes. For example, I have 5 type of cancers. So I need to add 5 neurons. 5 neurons. So if I have 5 classes of cancer, I need to have 5 neurons, right? And we need to apply a technique called apply an activation function called soft. Okay. We need to apply an activation function called softmax. Is that okay? So that is an idea. Some alternatives also are also there. For example, if we have binary classification, we should use 2 neurons and softmax. On the alternative side, we can use 1 neuron and a sigmoid activation function, right? Instead of softmax, we can use sigmoid, right? So that is up to you. Anyway. If we have a convenant like this, we can how to write the code for it, right? So can I show you? If you are a beginner, this will helping for you, right? For example, let it be, this is the, one second, let me take the screen clearly. Okay. Okay. So you can see that we have a convolution there. So to add the convolution there, initially we need to create a blank sequential model. Keras dot models dot sequential. Keras dot models dot. Then it is created in this way. You can see that. Initially we created a model and named it as TNN model MNS, right? So that is added with the, there is a function called dot add. That is added with the KS dot layers dot convectivity. You can see that, right? KS dot layers dot convectivity. And number of filters. So I think few know CNN, right? Few of the audience you know the CNN, right? So if you know the CNN only, you should be able to know the number of filters, what is number of, what is the filter size, what is 3 by 3. Let it be 32 is the number of filters and 3 by 3 is the size of that filter. Okay. So 32 such filters are there. So that can be given by here, 32 comma 3 by 3. Okay. And what is the activation function we are using at the layer? Activation is equal to blue, right? And this, note down that this is the first convolution layer and there should be some input for that, right? So to read the input, so for example, we will be dividing, we have the data set, right? X, and we will be having the data set X, and let it be that images are here. So we will be dividing the data set into two parts. I think our participants know this concept, right? So this is X train and this is X train, right? This is Y train. This is X test and this is Y test, right? X train, X test, Y train, and Y test, right? Then X train dot shape of one will give the dimension. For example, 28 by 28 is the dimension for that. So for the first layer, we should mention the dimension of the image what we are giving into that, right? So that's why for the first layer, we should mention what is the shape. 28 into 28 is the dimension for that, right? So do you know, dear participants, what is 28 into 28? Three type of images are there, right? One is binary image, one is grayscale image, one is colored image. Binary image, let it be 28 into 28. So 28 into 28 into 1 will be the dimension. 28 into 28 will be the dimension. But the pixel size will be 0 and 1 only. It is of binary. Okay. But here also grayscale image 28 into 28 into 1. But this time we are having the pixel size between 0 to 255. It contains pixels from 0 to 255. But in the case of colored image, it will be 28 into 28 into 3. 28 into 20. Why it is 3 means for a colored image, it contains three metrics. Three metrics. One is R matrix, one is G matrix, one is blue matrix. Okay, RGB. So that is 28 into 28 into 3. Here also the pixel size is 0 to 255. The 0 to 255. Is that clear? So hope you got the difference between binary, grayscale, and colored image. Can you chat me, dear participant? Is that clear? Can you quickly chat me? Is that clear to you? Binary, grayscale, and colored image? I think you know
Yes,
the
sir.
answer,
Yes,
right?
sir.
Yes, okay, fine. So I think you know the way to add the first layer, right? The convolution layer, right? And the second convolution layer, you can see that. You can see that the second convolution layer, and third one is max pooling layer, right? Third one is max pooling layer. You can see that max pooling layer. So KRAS dot layers dot max pooling 2D of 222, right? 222. 2, right? And another one is, it's very easy, right? To add dropout. KRAS dot layers dot dropout. And the rate at which you drop out to that is 0.2, right? Then flatten. KRAS dot layers dot flatten. KRAS dot layers dot flatten. And the dense layer. I'm going to add the dense layer. And it is of 128 neurons. So we need to apply review over there and finally drop out. If you are a beginner, you can take the screenshot or something, drop out, and finally we will be having a dense layer. So if we have 5 classes, what will be the number of neurons? 5, right? If we have 5 or 10 means 10 neurons. So that can be added in this way, right? Dense of 10, right? So this is a way we could do, implement a CNN, using KRAS of concept. Hope you got that, right? So dear participants, can you chat me? Is that clear? Can you quickly check? We will be having 5 minutes more. Can you quickly check what I have explained to you? Can you tell me? Because I know that I'm running very speed. Okay. Okay. So you're all with me, right? Okay. Okay, hope you will chat, right? Okay. So anyway, I'm jumping into the next part. So this is a way we create a CNN. So can I show some hands-on part for you? Because only 5 minutes left for us. And I think I will show you the course actually, what I'm having. Otherwise, normally when I'm taking the CNN workshop, I am writing from scratch and make the the audience to write. So this is the basic hands-on part here. Okay, this is the data set and result I have obtained on, the result I have obtained on another data set. Okay. Result I have obtained on another data set. So can I quickly explain? Can I quickly explain this one? This is explain what I have normally do. So you're all with me, right? No responses. That's when the chat box also waiting for that. So this will be the
Yes,
final
sir.
part of our session. Yes, right. Okay. So here you can see that mostly we require some that the like the header files, but we are having the packages. The packages we need to do. And how to, this is a platform called Google Colab. You know all that, right? You know the concept of Google Colab, right? So we can run the data on our GPU. We can run the data on a GPU or a CPU. Okay. We can run the data on a GPU or a CPU like that. So our computer doesn't have any CPU, oh sorry, GPU. Sometimes some computer will be having graphic card support that will be supported by GPU. Otherwise, we need to rely on other kind of sources. Sometimes we need to purchase Kaggle. Free Kaggle is there, and we can purchase the Kaggle. We'll get an additive GPU service. We work on Google Colab is a fine platform, but sometimes we work on that time the crash. Most time it will be crashing. So we can purchase Google Colab, right? So the purchased version of Google Colab and the purchased version of Kaggle will help us. Otherwise, we need to, in the previous college where I have worked, TK college, it will be in the center, our department of AI have a server with us, NVIDIA Tesla 800. There where we have done a lot of experiments. So otherwise, for a beginner, you can try the Google Colab. I think most of the participants, you know the concept of Google. So you can see that we should upload our data. We should upload our data. In the left side, you can see that where can upload, right? But at the same time, I recommend to upload all the data in your Google Drive. Okay, all the data on your Google Drive. Their data set will be. You can see that the ideal data set is there, right? The ideal data set is there, right? So you can download you can start from the subchallenge 2 actually. So you can have the 4 classes or 5 classes are there. So that 5 classes of folder you can place in your Google Drive. Okay. And after that, you can assign, you make the data set into 3 folders. One is for training, one is for validation, and one is for testing. Using the training data folder, in the training folder, you place 5 class folders of your disease. In the validation folder, you place 5 folders of your disease. In testing folder, you place 5 folders of your disease. Okay. So you can arrange in your dataset and you can assign the path here. Okay, that's what I have done here, right? And another thing, you can mention the data. For example, the images might be appear on different sizes, 328 or 210 into 210. You can customize it in a standardized way, 224 into 224. Is that okay? And what batch is? Batch is equal to 32 means it doesn't mean that 32 batches are there. Then for a single batch, it contains 32 images. Okay, from the entire data set, you take 32 images for a single iteration. Right? That's why we are taking classes. And we are assigning a variable called a train dataset, in which we are train dataset to flow from directory. What is that? Train dataset to flow from directory. We can read the dataset from your folder. What is that folder? I have mentioned that 3 folders you should create, right? One is training folder, validation folder, and a testing folder, right? So from the training folder, you can read that. And another thing, second thing, target size. So already I have mentioned that the target size is 224 into 224, which a batch size of 32, right? So this is the target data set with the batches. So if we are imagining having 210 into 210 size, 320 into 320, it will read only in the format of 224 into 224, right? You can see that. And you can see that we should give a class mode is categorical. I'm not going to explain detail because we can give multiple types. Sparse categorical, binary, we can give. Categorical means if the label is properly assigned, we can use categorical. Let it be there. And this you should perform the training data. This you should perform for the validation set. And this you should perform for the testing set, right? So once this phase, so far we have implemented the first phase of our model. So after the phase, we should go for our, and this we can call it as a pre-processing. We can call it as a pre-processing because we are adjusting the size and adjusting the batch size of the data, right? And the next phase is the training part, that is a CNN architecture. So this CNN architecture, I have already explained to you, right? Already explained to you with the various layers. Convolution layer is there, max pooling layer, convolution layer. You can design or custom your own. That will call it as trial and error method. You can try by your own layers and combinations, and you can get the accuracies, measure observations or all there, right? So you can take multiple layers and you can try the experience. Right? Is that okay? And then you can compile the model, right? Compile the model means when you run a C program, you will compile it, right? So the operation is entirely different, okay? The scheme is entirely different, but you can see a term called optimizer. I think some of the participants, you know the concept of optimizer. Lot of optimizers are there. Stochastic gradient descent, SGD is there, Adam is there, Adam W is there, RMS prop is there. Lot of optimizers are there, right? So we can pick one of each optimizer. Each optimizer has its own duty. When I teach MTech, we will have in detailed mathematical derivation for each and optimizer. Right? So then I need to describe about laws. Lot of type of laws are there, right? Sparse categorical cross entropy, categorical cross entropy. Lot of cross entropies are there, right? So each one have its own purpose. Okay, that I'm not going to explain now. Then we can introduce a technique called early stopping. For example, we are performing or checking the accuracy of, for example, 50 iterations or 50 epochs. There's a difference between epoch and iteration. If I'm experimenting it for 50 epoch, for example, if there is no change in accuracy for the next 5 epochs, we could stop there. So that's why we are giving patience is equal to 5 and we are introducing early shift. So finally, we are generating the model fit using the data set what we are giving based on the number of steps what we are giving, based on the number of epochs what we are giving. So use that, we are creating the model. Finally, we are drawing two graphs. One is training graph as well as the validation graph. Training accuracy as well as the validation accuracy, right? So for drawing that graph, it is available here, right? So it is, I think I can share the PPT, sorry, I can share the code to you, right? I can share the CNN code to you. It's not, because it's simply available everywhere, but ChatGPT is there, but some errors definitely will be there. But what my code is very clean. It can be readily available to everyone. Okay. So I am giving to you for you. Okay. So initially I have made lot of mistakes. Then I reduced the number of code. Finally, I have made in this way. Okay. So this will be the finest way. Then you can check the model accuracy and effort as well. So you can simply paste your new data set in your path and check what is the, after having the training accuracy training loss, then you can predict the class of your cancer. Okay. So that code I will take into you. What you want to do is that you simply download the data set and make the data set in your way that the code works on that data set structure. Okay. So you please arrange your data set in a way that the code will run on that. Okay. So please arrange that. Okay. So what you want to create is 3 data folders: train directory, validation directory, and test directory. And in train directory, you please give the 5 files, and validation directory, you give the another 35 files. 5 classes. That's right. So please run the code. I know that I am running out of the time. So in the short time, I have explained a few things. I know that this is a vast area, right? This is like a ocean. I have just mentioned about few drops earlier, right? So I think in the last 2 days, you have patiently listened to me. If this is a CNN workshops, I will go to each and every line. Okay, I will make the audience to do that. Mostly, I will give a shall I wind up now? I know that this is a procedure of FDP. This is not like a workshop. So within a short time, I have tried my best level to convey you about first one, medical imaging concept. Second one, lung cancer concepts in medical imaging using AI. And the third one, I have shown you the retinal imaging part. And the fourth one, I have shown you cancer. So dear participants, is that fine? ഞാൻ നിങ്ങളെ വലുതായിട്ട് ബോർ അടിപ്പിച്ചില്ലാന്ന് വിശ്വസിക്കുന്നു. കുറച്ചുപേരൊക്കെ ശ്രദ്ധിച്ചിരുന്നു എന്ന് വിശ്വസിക്കുന്നു. ഓക്കെ. I think you all have attended my session. There I am. So is that okay? Shall I wind up now?
Yes, sir.
Yes.
Anyone? Any doubt? Okay, I think there is no doubt. Okay,
Ma'am, I got some questions. Can I reply that?
okay. Yes, sir, yes, sir, yes, sir.
Yes. Professor Prashad, please suggest some research gaps. Sir, research gaps on which area? Medical imaging or specifically on retinal imaging or diabetic retinopathy? Can you chat me? And second question, how to select the deep learning model for a disease? Sir, actually, madam, actually, we need to experiment it actually. Okay. We need to experiment because it differs for the data set. Number of images, quality of images, the size of the images, because the input size for inception is entirely different for the input size for AICTE. Okay. So it depends upon the trial and error method. Okay. And for publication part, we should take care of the recent advancement of deep learning algorithms. So that only I'm repeatedly saying that only that the paper will be published nowadays. For the gaps in disease recognition actually, sir, see, I don't prefer retinal imaging because these are all saturated. Okay, I have started in 2016 or 17. So that time it was very least explored. Then a lot of people are using that. Then we can use the OCT images. Okay, apart from the fundus images, we could even fundus OCT images. Better you could try some. You can take some OCT images. That's why don't go for fundus images. Then you can try some 3M kind of scan images. That will be challenging one and the chance of publication is very high. Okay. Okay. Any other questions? Okay, if there are any questions, yeah, okay. Okay, ma'am, you please continue.
Okay, sir. On behalf of KMEA Engineering College, I sincerely thank you for today's session. Your PhD research on diabetic retinopathy showed us how AI can support the early detection in healthcare, and your step-by-step explanations with the examples was also very fine to understand complex ideas, and also about the new topics like wavelet CNN, and also it was also wonderful to know about broadened our knowledge. So we truly appreciate your time and effort, and thank you, sir. Thank you so much for coming and taking a session. Thanks, sir.
So thank you, dear participants. We will see you on another occasion. So thank you for hearing me. Thank you. So thank you. Thank you, organizers. Thank you.
Sir, we request all the participants to kindly turn on your camera for taking the photos. Okay, thank you. Thank you so much.
Okay, sir. Thank you. Thank you, Sharina. Okay, now it's time to continue with our next session. So we are now about to begin the second session of today, that is session 12, on AI-powered healthcare transformation, building secure human-centric solutions for patient care management. For this session, we are honored to welcome our distinguished speaker, Mr. Neeraj Manoharan, co-founder, director, and COO of Reafai Technologies Kochi. Neeraj Manoharan leads product and platform strategy at Reafai Technologies, focusing on generative AI systems. He is specialized in building human-centered AI assistants that seamlessly integrate with business systems, deliver measurable outcomes, and maintain the highest standards of privacy and reliability. His team have developed production AI across healthcare, aviation, banking, telecom, and consumer sectors, serving millions of users through multilingual and omni-channel sessions. He is also patent holder in intelligence, reflecting his innovation contributions to AI research and applications. One of his notable works is the design of WhatsApp native assistant that supports mothers with appointments, lab building, and postnatal care while safely integrating the hospital systems. Under his leadership, RIA has received global recognition, including the prestigious Dual Crown of the Year award. He is also a sought AI, Day6, and secure healthcare innovation. With great pleasure, let us extend a warm welcome to Mr. Neeraj Manoharan to begin today's session. Welcome you. Thank you.
Thank you so much. I'm audible, right?
Yes, sir.
Yes. Yes. Good evening, everyone. Very good evening. Hope you had a great session before. So, myself, Neeraj Manoharan, as Lija has already mentioned, I'm the co-founder and CEO of Reafy Technologies. So we are an AI company started back in 2013 and works primarily on AI-driven applications and human-centered AI use cases in different verticals. Like we do for consumers in mobile applications, we do for different enterprise clients across different verticals. So I'll quickly be going through all those when we start. So before we begin, I want to quickly give an introduction on the kind of session that you guys will be experiencing. First of all, it's a privilege to be here. Thank you for everyone for joining. So basically, we want like I have prepared a set of slides for presenting. I'll be presenting it soon. So I just don't want it to be driven through the slides. I want everyone to think with me and maybe imagine with me as in like we are trying to understand or I am trying to shed some light on agentic AI, as you all have heard, like might have heard before. I'm trying to shed some light on agentic AI and what an agentic AI era in a healthcare system would look like. So we personally have done an agentic AI use case. So what we do is primarily we have a patent. In 2013, we filed for a patent and we received in 2017. So based on that patent technology, we have our own model called R10. It's the first letter of Reafy, R10. So it's an AI model. So we built it in collaboration with Google Cloud. So we are one of the biggest Google Cloud Premium Gen AI partners in India. So what essentially we do is like we create custom trained models for different use cases in different verticals. So that is what we essentially do. And related to healthcare, that's the whole point of our discussion here. So in healthcare, what we have done is we have done an integration with one of the most leading pregnancy care in the hospital network chain in India. So what we have done is a customized version of R10 for their customers for handling their queries, for appointment booking, for helping them to reschedule or understand or solve their queries and such actions. So that is our expertise here. So to bring more context into that, there are very few generative AI-driven agentic AI use cases that has gone live in India. Like in India, when you take it as a whole market for generative AI, in agentic AI, what agentic AI is basically means like we interact with AI in ChatGPT or Gemini or in Cloud or any similar formats. Like so, basically, what happens is like a conversation is happening, but no actions can be performed through that. For example, in a hospital network, if you are to call a person and ask for a booking, they'll be booking on behalf of you at that hospital. So similarly, if an AI can understand things and take actions on behalf of you, that will be what is called as an agentic AI. So we'll be deep diving into more what agentic AI is, what like agentic AI in healthcare is doing right now, what are the possibilities into the future. So let us begin. Before we quickly move on, I just want to see a show of hands here and just see if that works. Like how many of you have tried more than two AI platforms? Like if you say, I assume ChatGPT is a no-brainer for everyone. I assume there is the second one. How many of you have tried more than three, like more than two? I mean, at least three AI platforms to do anything like to edit photo or to create text or research or anything? Yeah, let's see a quick show of hands, or you can just ping in the comment section. I'm not seeing anything. I think I'm not seeing the comments. It's coming in chat. Have anyone tried more than one? Nice. So everyone has tried at least one, right? Everyone has tried at least one AI platform to do any AI related task, right? Great. I'm seeing some thumbs ups here. Yeah, great, great. All right. So moving on, I'll be quickly sharing. Just confirm if you guys can see the. I need the presentation permission. Just a second. Just a second. The host is giving me the permissions to present. So as we wait for that, so basically what today's topic is, like what I'm trying to communicate through this session is what an AI powered healthcare transformation look like. So what are the opportunities here? So what are current advancements that has happened in AI, the healthcare transformation through AI, and how we can build a secure and human-centric solution for the patient care management. So the session is not about that data training or related to any medical imaging or any as some of other sessions are, like we get to know more about the patient disease related informations or such extractions are possible. So this session is more focused on the patient care. Outside the treatment segment, there is a huge market for patient care, like how a patient would interact with the hospital, how a patient will be handling his queries, how appointments happen. All those areas, there is a huge market and huge possibility wherein agentic AI could step in and actually help the actual the patients or patient supporting members. Yeah, I think I still don't have the permission to share the deck.
One minute, sir. 1 minute.
Sure. Thank you. Yeah, I think I got that. Everyone is able to see the presentation, right? Just confirm.
Yes, sir. Yes, sir. Yes, sir.
All right. Okay. Thank you so much. All right. So let's get started. I've already given the introduction on the topic. So basically, what we'll be like going through, what all sections we have. I have a short, brief slide showing the contents of the presentation as well. So quickly again, I've already mentioned about our company, what we do. So we have 100 million user base in mobile applications. Also, we have done 5 different vertical integrations. Like in banking, we have done for Federal Bank. In aviation, we have done for Indigo. So Indigo have a live WhatsApp chat where you can chat and book a ticket. So it's entirely powered by RIA5 Arten in collaboration with Google Cloud. Uh, Also, as I already mentioned, we have integrated AI assistant for generative AI assistant for the pregnancy assistant, as in WhatsApp for Cloud9 hospitals, that is in healthcare. We have also done for telecom in Banglalink. Banglalink is the leading uh, telecom provider in Bangladesh. We have also done for Lakme, as you know, it's a beauty FMCG brand. We have done a beauty assistant for Lakme also. All these assistants are live across their web and WhatsApp implementations. So what Artan essentially does is for their customers, like for each of their customers. So for Federal Bank, what FEDI is the name of the assistant. So what FEDI does is like it helps to understand transactions and perform transactions and like reply back to the queries that a banking user might have. So each vertical, what we have done is like a separate, entirely independent and a custom trained version of Artan will be deployed for separate clients. So our focus will be on the center one, the healthcare integration that we have done. So what is our approach to an generative AI? So as I've mentioned, an ethical human behavior is what primarily drives our approach to agentic AI. So what we try to do is like when we work with an organization, we try to understand what are their high volume tasks what are their high volume use cases. We list out their like how an employee or a person at their end would solve that. So this will be a simple ideology that you guys or anyone who will be researching or working on an AI use case can apply on. So as in like before we start on the solution, we first try to understand how yeah. I saw the message to add Lijamis to the host position, right? I'll try to do that. I'm not able to see that immediately. I'll try to do that in between. So yeah, moving on. Yeah. So moving on, what we can like try to do when we approach an AI driven problem is that we can try to understand how how a human would do that. Like it will be the most simplest form of approaching an AI driven solution. So we just think of it like how in any version human would be approaching this problem in a very similar way. We could try to create an agentic AI driven human, or I would say AI driven agentic AI, which can perform similar actions with similar skill sets and technical requirements on behalf of that person. So that will be the that will be the overall approach that we take when we like do an agentic AI approach, and when we try to apply an agentic AI solution into a new use case or a vertical. So for example, in a healthcare, what we can do is like how a person at a hospital or a hospital network would try to solve this problem, and understanding that problem, breaking it down into different steps that they would do to solve the problem. Then we will have a blueprint of how an AI could do that. So this is the simplest approach that we take. So quickly giving a session overview over here. So what essentially we have covered is like in 6 different modules. Roughly like 60, 70 to 80 minutes are left. So we have 6 modules to cover. Quickly giving an overview of that here. So in the first module, we'll be covering why is the timing right? Like why is it important now in healthcare and AI? Then we'll be doing like what is the transformation in technology that has happened? Like what is change that has happened in recent times compared to what was there before? And also then the third one will be entirely the case study of our agentic AI implementation in healthcare that I've already shown for the pregnancy care in Cloud9 Hospital. So I'll be briefing through that. Then we'll also go through what are the security and compliances that need to be followed. Also, we'll have a tech deep down. And finally, what are the future and opportunities for innovation in agentic AI? So this will be the overall session journey as such. The possibilities are definitely infinite. We are only scratching the surface of what an AI could do in a healthcare system. So let's get started. So first one is the AI revolution that is happening in healthcare. Yeah, I think she got the permission. Okay. So the first like module covers basically what is the time right now. So that is what we are trying to cover here. So let's see the big picture here. Like, why is health AI in healthcare important now? Let's try to understand that first. We often hear the phrases, right? Like AI will change everything, or like everything is changing based on AI. So such phrases we are hearing, but in reality, what is the problem here, and what are the uh, like what is the essential time for AI to intervene into an healthcare system, and why we believe it is right now. So let's see that. So basically, the healthcare systems as such, like they have a lot of pressure uh, in case of rising patients volume. So as like basically, uh, at least through the WHO specifications, the patient to doctor ratio, the doctor to patient ratio is 1 to 1,000 or something. Basically in India itself, we are around 1 to 1,500, and in most countries, even in developed countries, that ratios are even higher. So the rising patient volume is one of the challenges that our hospitals and even the hospital networks, even the biggest hospital networks in India are facing. Basically, the aging population or chronic diseases, even the common diseases like diabetes, hypertension, the volume of increase in that, everything is just increasing that gap, and the gap is widening, and it is important. Uh, yeah, it is important that basically this gap gets filled through some intervention. So currently, another big challenge in hospitals is like hospitals run on multiple disconnected systems, like one for billing, another for labs, maybe another for appointment scheduling. These data silos, like what we call is like a data silo, because they are separate from each other. These records, these data are independent to each other, and they do not communicate between them. So what happens is like the information is fragmented, and the patients ended up repeating themselves at every counter. So and the expectations are going up. Like today's patients in the growing up era, their demands to the hospital treatment and hospital networks are going up. And then there is definitely, as we all know, there are resource constraints where we are like even in nursing and office desk and everything, like in related to the hospitals, we face a critical resource constraint due to both availability and financial implications. So that is the current situation that is there. But let's look at the um, overall like market landscape here. So what is like healthcare AI market looking like? So basically, based on research in 2024 and 25, the market is valued around 45 billion globally. No, it's like basically growing at a rate of 30 to 35, 30 to 37% annually. That is one of the fastest growing sectors in AI globally. Like you have to understand, AI is growing globally. It is impacting global dimensions in many sectors. Like we understand AI is happening in everywhere, in manufacture, in banking, everywhere AI is intervening, and AI is definitely making an impact. But we are seeing one of the biggest and fastest growing impacts and fastest growing sectors for AI and AI based applications within within the healthcare sector. So that is a very important thing to understand. And basically, 85% of healthcare leaders are willing to invest in AI. So basically, there are already hospitals and hospital chains in India which are adapting to or willing to adapt, or in the early stage of experimenting with AI technologies. Some countries like Singapore are already leading the way with many AI driven systems and applications well placed into their own the government driven like healthcare sector. So basically, what we can understand here is like the AI market is already a big one, and it's growing on at one of the largest or biggest pace. So it's definitely going to be one of the biggest markets for AI in the coming maybe 5 to 10 years. And how have the technology evolved? So this is the another one important thing that we need to understand. As we say, the time is right now. So why is that? Why is technology any different now? So I'll just go through how the technology has evolved over the years. Most of you might be familiar with these terms. It used to be rule-based systems initially. Rule-based systems, as we know, will be if then else. Those conditions will be baked in. So if a patient's blood sugar is greater than X number, then it should be marked as high. If it's not, it should be marked as low. It will be basically like a if-else conditions. So such rule-based systems is where we began our journey in technology in healthcare. That was long before. Then we moved on to machine learning. That is when the predicting of maybe high flagged diseases or very narrow and domain specific items we are able to machine learn and implement as systems. It could only be done to very few, and it was very expensive to be done. That was this phase of machine learning in healthcare. Then we moved on to deep learning when we brought in the neural networks, things like medical imaging, detecting tumors, scans, etc. became like they became the norm, and it really empowered a lot of medical transformations. Then came the large language models. As we all know, the ChatGPT is one of the large language models. Now the AI here can process unstructured data, like you can just upload a prescription or a doctor's note, and ChatGPT or any such LLMs will be able to give you an information or give a summary of it. Or if you can give a lab report, it can find you what are the main issues there, and such things. So that is when the large language models uh, came to play a big role in the healthcare section. And now we are in the agentic AI era. So what agentic AI today's generation happening is like they are not just answering questions. So this is where I want everyone to understand as clearly as possible. So how an agentic AI would respond is like they are not just answering any like text, or they are not answering just questions through text or image or like through sound. Like they what they essentially do is like they will be able to take actions on behalf of you. So that will be the agentic AI era that we are talking about. I think of it like the classrooms or teaching evolving from Blackboard to our head projectors, then to PowerPoint and machine like multimedia, then smart boards, then personalized AI tutors. Like similar evolution is happening in the healthcare. So like I want everyone to imagine, would you prefer an AI just answer questions, or if it can do in a secure way, if you want to in a secure way, if it can help you into book appointments, or if you want to pull a latest test report, or it will automatically remind you to do such and such things. So that is where agentic AI becomes important. That is the role of agentic AI essentially, to take actions on behalf of us, to help us perform action. So that will be the essential role that an agentic AI would be playing. So moving on to healthcare integration challenges. So what are so we understood there is a market for it and it's growing. We understood what are the problems. So what are the real challenges here? So as I mentioned before, uh, the data that separate between the hospital systems. Within the hospital, there are multiple layers of data separations, making it data silos. That will be the one challenge that we have already discussed. And also another thing will be like hospitals run on years old system, which will be very hard to upgrade from. Also, we have like these standards and protocols like HL7 or FHIR, which is critical for the operations. And what our newly created agentic AI frameworks should actually be supportive or coexistent with that. And also, there will be issues related to the operational challenges that already the hospital's network faces. That those same challenges will also come when we try to bring in the agentic AI integration into the hospital systems. Also related to the data privacy, right? So we understand there is HIPAA, there is GDPR, and there's DISHA that is proposed and partly implemented in India. So these uh, uh, doing these actions, definitely doing these actions more securely is what we want to do, and doing that securely and integrating them into the existing system. So that will be the one of the most challenging aspects that that the healthcare integration would require. So understand. So moving on to understanding the digital age patient, right? Uh, like I want to give an overview of what as a patient expects from a hospital network, and also what's currently happening. Like the digital age patient of now is really uh, demanding for an instant access. Like they want uh, to get responses as fast as possible, because that is what they get from everywhere else, like from a messaging platform or from a social network. They get instant gratifications, they get instant replies, and they are used to that. So what digital age patient is like a patient who prefers always digital age mechanisms and expects similar experiences from the hospital networks. So what essentially the healthcare facilities need to step up, or the patients trying to reach their expectations will be to provide maybe an instant access like 24/7 availability, or maybe an immediate response when they need, maybe some availability checks, or such and such things, without maybe calling and waiting in a maybe waiting for hold for some time, or maybe trying to come to the hospital and wait in a queue for a record. So all those things, they would like to get it like maybe faster, and also they need it to be available whenever they want. Also, there expects the personalized care and a seamless experience, which they from what I mean is like a unified experience through all touch points. Maybe when they come to the hospital, or they use the app or use WhatsApp, they expect a unified experience in all these. Also related to the transparency and trust, they need the platform and the system to be to be trustworthy, and also they expect it to clearly communicate, and whenever there is a requirement for the communication for back and forth. So these are the basic essential understandings we should have of the digital age patient. And why this is important is because only then we understand we understand the problem, and we understand their expectations. Then only we'll be able to create a solution which is ideal for them. So essentially, what we have covered in the first module is like what the current landscape of AI in healthcare looks like, what are the promises, what are the challenges we have, and also what are the expectations of a digital age patient. So I hope these portions are was easy to understand. If there's any doubt related to the first module, please do share in chat, or please do raise hand and ask. So quickly moving on to the second section, the second module. So here we deal about what makes an AI agentic. So that is what whole point of the second module is, like how an agentic AI would do things versus a traditional healthcare maybe a software would do. That is will be the difference that we'll be covering here. So what makes an AI agentic in the current landscape, right? So we all understand how an AI works, how an AI chat works, or how an AI an application works. But what the difference when we moved on to the agentic AI is something like a next generation AI that is contextually aware. What we mean by contextually aware is like it remembers the patient history, or like try to authenticate user and understand what he is or he or she is. So always he's always aware of the context in which he is going to communicate. It's not like the same software or the same AI is not going to talk to everyone. the AI that is talking to me will be the one who has an understanding of what I am, what I have done previously, what the kind of bookings that we have done, and also the kind of maybe hospital visits I have done, or my recent appointments. All those things he will have an understanding about. So that will be the first thing. It is a contextually aware AI. And the second thing would be it is capable of reasoning and planning actions. It's like it can understand and reason when I ask something. It can do like plan for actions on my behalf. It can maybe reschedule an appointment, or like I ask for a hospital record. So it can try to plan what action it needs to do. And finally, it would execute the action based on the user confirmations in a secure way. So these are the three things that an agentic AI would do. So first thing, it will be contextually aware. Second thing, it will be capable of reasoning and planning actions. And third one, it will execute workflows autonomously without a human intervention. So that is the essential capability that makes agentic AI different. Like it's autonomous in terms of the defined scope and defined um, skill sets that we have taught them. It will be able to perform actions and operations on behalf of the person who is it's communicating to. So it is different from the rule-based bots, which was what we had before. And so basically, agentic AI just don't answer. They plan, decide, and act on users' behalf, I would say, but within a safe boundary. I've already mentioned how a contextual understanding would work. It is basically it understand a person from the past interactions, maybe from EHR, electronic health record, or a current task context. Like it understand if there's a pregnant person trying to communicate and she's 32 weeks into the pregnancy, the assistant would be knowing that and trying to communicate. Maybe he already knows the assistant already will know when the next appointment is coming up. So he already have those contexts right, like a person would do, right? So a real person who knows me personally would know these details, which then he can use in our conversation. Similarly, an agentic AI framework assistant will be contextually aware and understanding, and also it has multi-step reasoning. Uh, so what basically that means is like it can break a user's goal into steps. So maybe we are like when from a person's or from a say a patient's standpoint, they'll be just asking for a task. But what essentially happens is like uh, that task need to be performed in separate number of steps. Say you need to break down that goal into different steps. So for example, I would say a person is trying to send a voice note in WhatsApp and asking for a doctor reschedule or something like that. So what we need to do, like the agentic AI would have to verify the identity. It would have to check the doctor schedule. It will have to book a slot. Then it will have to confirm to send the confirmation. Maybe cancel the other appointment and set a reminder for again reminding the person maybe 1 or 2 days before. So all these are number of different steps involving communication and software interaction with different modules of the hospital chain, and also in perspective to the user, it will have to clearly communicate what it have done and share the maybe the new booking details to that. So it's not a single response like you when we chat and we get a response. It's not like that. It's multi-step reasoning. It will break down into steps. It will perform. It will first gather information to perform each step, then create a sequence of actions that need to be done. It will get a confirmation from the user and perform uh, the user goals into steps. And also, it's the agentic AI is more goal oriented, meaning it's optimized towards an outcome. So when we work with an enterprise organization, so they will have a certain outcome or a set of a number of outcomes that they would prefer to happen in terms of maybe having a successful appointment booking, or minimizing friction, or minimizing the call to their call centers. Such goals will be there. So our agentic AI will be trained in such a way that it is optimized to reduce the outcome, to increase the outcome and maybe reduce the negative effects of that. So it will be more goal-oriented actions. And also it's a real-time adaptable system. When they try to perform an operation, say if some appointment booking systems are down, it will be aware of the current situation and will informing the user based on that. So that's what make an AI agentic. So I hope this is an important slide where we try to understand how it's different from a traditional uh, an AI chatting software. So basically, if say for example, I would say if someone calls to the or someone messages our AI agentic AI in WhatsApp and say like this Friday I would like to get my appointment, and also I need to maybe get a test done on the same day nearby in such city, say example they say in Chennai. So what are the bot will do is like they will check for example, say said Dr. Rao, they'll check for Dr. Rao's OPA timings. You'll find a slot, maybe if a slot was asked, if it's not there, you'll present with an option so for the number of slots that they have. And it also will parallelly check what all labs that person will have options to do in Chennai, and also maybe suggest similar options for that person. So this will be the kind of operations that will be done. uh, we'll do a quick comparison here so to easily understand. So to versus the traditional chatbot and the agentic AI systems. So in the chatbots, we have a predefined response trees. We go through a chat thread, maybe in ChatGPT or Gemini or any chat applications, AI driven. We'll have a predefined response tree, which we'll be going through. But in agentic AI system, the response will be dynamic, and it will have infinite number of branches. Also, the contextual awareness is a main difference that we have. And also mentioned the agentic AI systems are multi-step, which has multi-step reasonings. Also, it's aware of what systems are active and available for the patient or such person interacting is available. And it's also aware of the systems that are not available, which they will inform, maybe like a human would say that such and such systems are not maybe are down right now or in technical maintenance, so we can reach out in a later point in time. So this will be the understanding of what a traditional versus an agentic AI systems looks like. And also I'll quickly give an overview of the LLMs in healthcare. Agentic AI is powered by LLM plus tools or LLM fine-tuned LLMs. So in our case, we are working on the fine-tuned model of Gemini in partnership with Google. So similarly, there are a lot of LLM tools and certain LLM models which are directly trained for certain medical use cases as well. So, for example, everyone might be familiar with ChatGPT. So, ChatGPT 4 variants have a very strong performance in medical reasoning and clinical documentation. Same way, Google's Gemini family supports multimodal reasoning and healthcare specific fine tuning for specific task and Q&A and such systems. And we have also been working, or the healthcare systems have been working with MedPalm and similar medical specific trained models, which are already available there. So the capabilities are there with the LLMs or the generative AI systems. We just need to create systems where we can tap into their potentials and create a safe environment for them to work, a restricted one where they are only allowed to maybe tread through the paths that we have recreated. So such protocol creation and utilizing LLMs into such a production grade environment That will be the key essential things that we need to understand when we work with LLMs in healthcare. So what we kind of do is like we have methods like retrieval grounding, we have tool guards, and we have role-based access. Uh, Basically, a person in healthcare, maybe a person handling the calls, who's attending the call center number. That person will in the organization will have a certain level of roles, right? So those role-based operations will be similar to what we do with our agentic AI implementation. So we believe, as I've initially mentioned, so we believe how to approach an agentic AI solution is to understand how a human would solve that, how the current system at a human level works. We try to create similar systems and similar methods to replicate it through the agentic AI. So, for example, I'll quickly like take you through the philosophy and how an ethical human behavior is replicated based on like the implementation that we have done. So, what we try to do is like we don't try to create chatbots. We try to design ethical AI employees. Basically, an AI employee would be same as the as part of an employee at an organization, but we'll have an ethical grounding. And also, if you say in case of healthcare, it will be embedded into the hospital team, so it will have a clear grounding and ethical boundaries that are built to perform specific tasks. So uh, the next possible implementation that we will look at is identifying the task. So what are the tasks that we need this ethical AI employee, or say the ethical AI agentic AI agent would want to do? So we try to break down those tasks. So if, for example, a person handling with the hospital records would be different from the agentic AI that's going to handle maybe at a an appointment level thing. So we try to define different or try to identify different tasks, I would say, starting with what the real work the people are doing. It would be like appointments, it would be like lab results. I would say billing related or billing queries, maybe discharge follow up. A person gets discharged and he has some items to follow up. So we try to identify the task like that. There are many other tasks like related to there are home care solutions that are provided by many hospital chains right now, and also related to say maybe insurance or pre-insurance authentication, any such related tasks which are mainly repetitive but need a contextual understanding of what the I would say the patient or patient related information are relevant. But we try to identify the task and prioritize based on what the organization want to do. Then we define a personality. So this is this is the workflow how an ATAL model would be created for a new I would say organization, or maybe a new industry, or I would say any vertical that we try to integrate. This will be the flow of things that goes into the process. So while defining personality, it would be like uh, we want to set the tone. And uh, yeah, was anyone talking? All right. So I think more people are meeting. Yes, I just accepted that. Yes. Going back, what we were talking about is creating a tone and empathy when required for the personality of the agentic AI assistant. So it would be like maybe for I would say for an antenatal care, right? So we would want a warm, reassuring, or similar kind of persona. But for maybe a billing use case, we would want it to be concise and compliant with the system, and also maybe a neutral tone. So we kind of define the personality that we want here. Then what we kind of do is like we map the skills into the task that's required. So each task will require a certain capability. So for example, we want the skills for calendar navigation, for identity verification. So maybe if instance in insurance, we want it to quickly check up or pull up a policy lookup. Similarly, at a person at insurance, they will have an immediate knowledge of that insurance clause or policy, or they'll quickly look up in a document, right? Similar skills will be required for our agentic AI as well. Then another one will be document retrieval. Maybe some cases in some maybe booking related information or payment related places, we will need a capability or skills to initiate payments as well. And also maybe in some very rare cases, it will need skills to understand the locations also. So the kind of skills are required to perform the task that will be mapping out and being trained into. And we then we bring in the guardrails, like we clearly and specifically create boundaries and guidelines and guardrails, where we bring in things like safety rules, escalation criteria. So we have privacy boundaries. There is language sensitivity even when the user is in maybe in a bad tone. Even then, we need the language sensitivity to happen. And maybe there will be in most cases there will be a certain area or areas that we do not want the bot to answer, so we create additional guidelines for no don't answer or no answering zones as well. So it's like the guidelines clearly set for the basic guardrails and grounding of the agent. Then we apply the business logic. Then basically what happens is like up to this point, it will be like definitely the organization will have a say in the personality and the task to pick. But definitely each organization works differently. Like some hospitals have certain policy and maybe protocols. Some other will have a slightly different one. So in the business logic layer, we try to bring in the institution specific policies, like what are cancellation rules they have, pre procedures, maybe cutoff times, pricing, and different business logics are there. So we try to bring in that. And finally, once the team testing and extreme use case testings are done, we have an assistant or an agentic AI that behaves like a well-trained team member who's helpful, who is compliant, who is auditable, who has a clear audit trail, and is consistent. So, what essentially this process creates is like from start to end, we are trying to create an ethical AI employee. So I'll just go through it once again. We try the whole philosophy here is like how a human would do certain thing or how a human would handle certain situation in an organization. That is the exact same way we are trying to replicate in the implementation for our system as well. So in this case, as we can see, we first identify the task, we then define personality, we then map their skills, what are skills are required to do the task. Then we clearly set guidelines and boundaries in the fourth section. Then on top of that, we apply the business logic. So once all these actions are performed, we create an Artan version that is required for the institution. And then on top of that, we do team and extensive rule-based testing to ensure it still holds the guardrails, it's performing to its needs. And once it's completed, we have the ethical AI employee, which is ready for maybe closed user group testing. So this is the overview of how we would do that. I'll quickly go to take you through like easy questions that we have. Say, how would like what persona would you want for a particular job? So that will be the thing that we try to understand. Would you hire this person for this task? What skills he or she should have? How old that person should be? Where should be they from? All these can be fine-tuned in our persona section. And also what skills they have, as I've mentioned, the skills and the task, they're very correlated. So here you can see different versions of a person, maybe a same person, but in different skill sets and different ambience, right? One is a painter, one is a singer, maybe one is a writer, one has expertise like thinking, one is good at computers. So all these different versions would be different in a way how they speak, how they communicate, how what guardrails they have, what their thinking process are. So this will be a framework in which we create an ethical AI employee. So this will be the end of how an agentic AI looks different from the existing AI chatbots. So quickly we'll take you through the yeah, you're able to follow, right? Like I completed 2 modules, but is it easy to follow or should I slow down or something? All right. Thank you. Thank you for the feedback. So I'll just move on, maybe a bit fast, bit at a bit more pace to finish the things in time. So module 3 will be about the real world implementation. As I mentioned, we have a real world use case for a hospital care system, which Google has already done case study on. What essentially we have done is we have created an agentic AI in WhatsApp, which is available 24/7 for the customers to talk to and maybe perform actions, to have declare queries, to reschedule, to book appointments, or like a lot of different things. So that is basically I'm taking you through the through what we have done there. In module 2 we have clearly I've tried to explain how we create the system. This is kind of like a walkthrough of a real system that has been created through the process. So the challenge mainly here was supporting digital age mothers. So as the pregnancy as our client was the pregnancy care solution expert, and they had a chain of hospitals across mainly in South India. Also, they are one of the leading hospital chains for pregnancy care in the region as well. So their problem and challenge was mainly in supporting digital age mothers. Like their expectations, we have seen what an expectation from a digital age patient is. Like similar to that, we have a clear expectation from the digital age mothers here. So expecting mothers today are digital native, meaning they have time constraint. They are also emotionally tuned in. They want timely and clear, maybe personalized support without always having to wait for maybe in a call or wait in a line to get things done, because like in that phase they expect things to happen. That's also a good thing also. And also related to the challenges that we have already seen in hospital, all those challenges are same available here also. So supporting them was the major challenge with our system. Now our AI agent is called Bump. So what Bump essentially does is like they kind of like a bridge between the mother and maybe the expected mother and the hospital network. It basically supports text and voice. So it have facilitated tens of thousands of sessions or handling more than 1 lakh messages. This was a couple of months back, so it has further increased from there. So it operates 24/7, meaning whenever they are in need, they could just open WhatsApp and send a voice note or chat with to handle any urgent situations of appointment bookings or rescheduling. They can just send a message and leave it with Bum, and Bum will be the one who will be handling the thing for them in their behalf. So it's a WhatsApp-based agentic AI. Also, it's a natural conversational interface where you can just chat with like a normal person. Also, it has the main important thing it has is the seamless hospital integration. Like we have a clear, strong integration with the hospital here, so that the actions could be performed. Maybe like asking for a quick document or checking up when the next scan is. All those things. Even rescheduling to a date with lower number of appointments to reduce the rush at hospital. They can even ask for that. So it's aware of what it's basically it is deeply integrated into the hospital system, having an understanding and able to perform actions on behalf of that. So as I mentioned, these are the quick highlight capabilities that Bump has. Its appointment management capabilities, able to book, reschedule, or manage appointments. It can access health records for you if you ask it for lab reports, prescriptions, and medical history. It also have home care services like request nursing, diagnostics. It can ask for home care service. It does not provide any healthcare service. You can ask for healthcare services and provide it through a schedule it for a later period. It's like Bump is like a bridge, not a person operating at a level for providing care. It will be the bridge to ask for a care, maybe request for a home care service or something like that. It will help you for locating the hospitals near you. Since it's a chain, it has a lot of different hospitals. It provides 24/7 support. Also, it provides you with proactive reminders when you interact with that. It understands the upcoming events like a checkup or an appointment and gives you reminders for that. So these are the core capabilities of Bump. So even when you look at a use case like an appointment management, right? So even there, the person would be messaging or calling or like sending a voice note for an appointment for next doctor. So the variables here will be like which doctor the person is referring to. Maybe they'll be only be referring through a first name or a second name. There will be multiple doctors in the similar name. There will be multiple hospitals in the region. So which hospitals was the person last visiting to, or which hospital the person is currently having appointments with. All those understanding for contextual information retrieval is required here to perform the next step of checking whether the particular hospital and particular doctor has an appointment slot for that day. So mostly what happens is like the appointment date will be full or it will almost full. So the system is designed in such a way that our agent, our Bump here, will actually find uh, the days to post that day. Like it will check how about next Friday. So it will say like the Tuesday appointment looks a bit tricky. It's quite full there. What about the Friday evening? Will that work for you? It will interact in such a way that how a person at a hospital would respond in a situation instead of just saying no, the appointments for that day is full. It won't be responding like that. It will be providing with a contextual answer of what can be done, similar to a person that when a person we call and schedule through a person, she or he would actually suggest us related to what possible solutions are. Similarly, Bump is equipped for that. And related to the smart integrations, I've already covered, I think that. So unlike the traditional chatbots, Bump is powered by agentic AI. It understands the context, follows the hospital workflows, it executes multi-step actions and engages patients. It's also delivering personalized human-like support at scale. So what transformation that has happened to in a patient level, that's also I think I've quite covered that. So that's related to the agentic AI real world use case that we have done and a quick overview of that. Now we move on to related to the security compliant and human centric design. So these are three important pillars when we talk about agentic AI implementations. So healthcare security, yeah, just a second. All right. Sorry for that. So related to the healthcare security and compliance network, as I've already mentioned, the compliance aspect here, also related to the frameworks that is available, the encryption that's required, or also the role-based access, logging, like complete activity tracking, reporting, and logging for the audit methods, and the compliance monitoring. Like we provide a dashboard for a complete monitoring and stepping in on behalf of at any time in like chat or conversation. The user can decide to switch to a real human, or a real human can anywhere maybe step into a conversation and take it up from there. So such systems are in place, and we also work like the HIPAA compliance. What I'm trying to say is these are all the essential components that is required for a comprehensive healthcare solution. For healthcare security to work, these will be the levels of security aspects that need to be handled. This will be the levels of role-based access that needs to be provided. They are regarding the audit logging and the compliance monitoring, interfering and taking it up from agentic AI to a real human. All those security and compliance frameworks are essential. So these are the main key items there, and also it's like related to the privacy aspect, right? So the whenever there is uh, a data-driven training, so we currently do not do data-driven training. So whenever that is required, that need to be done at a federated learning level. Basically, the data doesn't leave the hospital infrastructure. So that is how our implementation doesn't require the data to be pulled away for any kind of training. So we currently do not require that. But if any of the use cases that we do needs any kind of pre-data related to any hospitals or patient records, they need to be at a federated learning level. Also, we need to have statistical privacy guarantees, also related to the encryptions. I've already mentioned that, and maybe a collaborative analysis. As I mentioned, the collaborative dashboard that we provide is for monitoring always, and we have the team from our end also monitoring the system on a day-to-day basis. So that is the advanced privacy technology that will be required. And also being ethical in healthcare, again, similar to being ethical in many other sectors, it's really important here to bring out the ethical aspects of our agentic assistant, as in like treating everyone fairly, accountability, transparency. There will be a lot of bias that happens during training, and maybe inherently in the LLMs, if we have deeply worked with large language models, any large language model, you can understand there are bias. So we need to create systems that doesn't allow regular bias to happen in the process. Also, we have to be clearly explainable, like what our art and Dex, our Dex is our explainable module. What a Dex does is that it is clearly explainable in each step, which is clearly auditable in the logs. And also, it will have a high level of human oversight, as I mentioned, and continuous monitoring is required. So these are the essential components that would make sure a basic level of ethical AI is being implemented in the system that we're building. So these many components are required just to make sure the AI system, which we have already built and working, is compliant with the ethical AI part. And related to the human-centric AI design, so as I have already mentioned, how we can enhance the human capabilities is what we do. Also, we need multilingual support. So currently, we support 23 languages. So these are an essential component for a for an human-centric AI design. And also, it should be clearly and plainly communicated to the patient that they are communicating with an AI assistant. So in case of our bump, when we communicate with that, we'll be clearly saying you are conversing with an AI, and only if the user prefers to do in that way, he can further proceed. Instead, he can definitely go back to the normal route of chatting with a real person. Also, there will be cultural sensitivity, diverse healthcare practices. All those things are there. So basically, only these components collectively together make a secure and human-centric AI system, wherein we have the security aspects. We have already mentioned ethical aspects, and the last part will be the human-centric AI design principles. So these topics are very deep, as in we have to deeply understand each modules. Maybe each module will be worth separate sessions. So I'm not deep diving into that, but these are the main components that would ensure that we have a strong ethical boundary, a strong compliance and security framework, and we also have a privacy angle built into our system. So that's related to the security aspects there. Now on the technical architecture, here also I'm only going through the basics here. So I'm just giving a highlight of how we handle the what you would say, the primary aspects of implementation in a level of maybe hierarchical order, or just an overview of how we would do that. That's explained here. So we kind of rely more on microservices architecture here. As in the scaling of the system is primarily dependent on the users and the volume. So definitely we always prefer the microservices architecture, and each capability will be disjoint from the other, so that we can pull one away without affecting the other, or update one without affecting the other. And we also have things like API gateway, load balancer, we have auth services, we have AI services like our fine-tuned LLM models running, and we have data services working in like databases, audit logging, feed level validations, etc. We also have this like event buses, which should what kind of what essentially they do is like they create notifications when the reports are asked from a user. Maybe it won't be immediately available, but we'll say we'll get back when it's ready. Maybe a report generation process will happen, then an event will be fired. When the report is ready, we'll be sending back to user. So, for such systems, we have an event bus in place. We have a cache layer for low latency uh, requirements like schedules and upcoming appointments, etc. We also have this uh, the Kubernetes or the containerized services with auto scaling and health props. So like collectively, this will be a rough framework of how an enterprise level AI system could be in place for a maybe a college or a university or a hospital or any such systems. This could be a rough framework that could be used. Then I would say the life cycle. It would be like the data pre-processing. Definitely, we are all familiar with that part. Basic noise reductions, accuracy, and ensuring reinforcements. Those will be the things that be done there. And we'll have feature engineering, wherein we have to engineer for the individual features and capabilities that we are working on. Then we'll have fine tuning and model uh, updations that are required for our end. In our case, we create a fine tuned model, but maybe in another use case, it will be a custom model training or something like that. So that will basically train with diverse informations. In our case, what we do is we already have the fine-tuned RTN model, which doesn't require any data from the client or organization or the patient to work. So we already have a model that is ready to use. We only create the steps that I've already mentioned in creating the ethical AI employee. But in case of fine-tuning required use cases that need to be done, and also need to be within the, in case of healthcare, it need to be within the hospital's infrastructure itself. And then kind of like there are things like hyperparameter optimization, etc. And also deploying this also requires a certain level of processes in place like pipelines and testing pipelines, and also we need the as I mentioned, the real-time performance monitoring systems as well. Uh, so these are the basic things that need to be aware when integrating to healthcare systems. It will be like RESTful APIs. There are things like webhooks which are used to real-time updates. I've already mentioned the pipelines like queues, uh, Kafka, and similar queues I've already mentioned. There are graph SQL endpoints which can be used for efficient data fetching. Authentication systems also we have discussed, and there are industry standards for healthcare like FHIR or similar things that we have already mentioned. Then there are compliances on top of that. So these are aspects where integration need to touch upon. Uh, then once we have the system up and running, we need to maybe more like measure the performance and scalability. I've kept it in two separate slides. So a performance in terms of how it will perform to the user, and measuring in terms of how it is impacting the use case. Like when an organization does such an agentic AI implementation, we definitely need to track what are the success criteria here. For example, there are operational efficiency, cost reduction. Such headers will be there for for the impact matrices, right? So, regard to that, there will be definitely be more like impact tracking need to be done. So it will be a summary of like whole thing that we have done is like how a technical architecture would look like, what an AI/ML life cycle would look like, also how we integrate, and how we what are the essential items that we use for success tracking. So this module is also again bit more technical and bit more deep diving into the core of what agentic AI in a real world use case would look like. Now coming to the last module, I think we only have a couple more minutes. I'll quickly round the module up, and then maybe like uh, any feedbacks or such things or questions that need to be taken up. I'll take it in the last 5 minutes. So quickly winding it up with the future. So far what we have discussed is like summing it up, what we have explored today is like the today's systems and what has been happening, right? What are the potential opportunities that we have? What are the challenges that will be there in an agentic AI era? How a hospital management system could incorporate agentic AI into its workflow, and also regarding the technical and security aspects, we have highlighted certain elements or certain areas that need to be maybe thoroughly handled for ethical AI to go to production. As I mentioned, only few only few agentic AI use cases have gone live in India. So we are one of them, and we need to strongly follow these guidelines to make sure that's happening. So now we have a peek at what the uh, the future looks like. So next generation definitely looks promising and really powerful, wherein we have things like quantum computing playing roles like drug discovery, protein folding, etc. We have huge edge computing advancements that are happening. Edge computing means like basically high powerful computations that are happening in our edge devices like our laptops or mobile phones. There are models and frameworks that are able to do high performance computations in edge devices like a mobile phone. There are models like Google's Gamma 3N, which can run on an average smartphone, which can still perform and still compute at a high superior level. So those advancements are happening, and also there is a concept of digital twin that is happening across globe, which basically they're basically like an early pilot, I would say, to creating a digital twin of a true patient companion like a thing. And also there are a lot of advancements happening in a multimodal understanding. Like currently what I've mentioned is like the bump is capable of understanding in text, voice, and maybe a couple of images, but a deeper understanding through maybe a video conferencing, a real-time video conferencing that an agentic AI can take up are definitely coming soon, because those advancements and such technologies are evolving in a rapid pace. So these are peak of what or like these are glimpses of what next generation healthcare technologies look like. So as I mentioned, we are expecting predictive health modeling. We are expecting autonomous recommendations, real-time diagnostics, as I previously mentioned, and the multimodal understanding, like through video or live call understanding. So such things are also rapidly evolving. And there are definitely a huge academic research opportunity that is happening, throughout industries and academic sections. There is a huge space for exploration there. And the federated learning that I've mentioned, the closed learning iteration that's happening within a consigned organization or an environment. Then again, uh, the related to privacy and preserving AI and the human AI collaboration aspect. There's a lot of academic research opportunities, a lot of research areas that maybe research like people in working in research or research faculties can deep dive into, especially in healthcare and AI. Uh, Also, the career skills and the domain knowledge required to perform such certain actions, that's also have widely changed in the last 2 to 3 years. So the technical skills and domain knowledge expertise definitely will have a huge role to play. And the industry, academic industry collaborations, there are already frameworks that is happening, like industry relevant course design is happening into the academics. Similarly, the joint research projects that's happening right now, there are a lot of joint research projects that's happening right now, and the real world experiences through the student internships and such things would bridge the healthcare AI requirements and fasten the overall the research and development in the healthcare AI sector. Uh, so basically, I'll quickly like summarize through the section that we have done again. So we started off with what the current agentic AI. Sorry, we started off with the AI revolution, where we discussed regarding the healthcare systems growing under pressure and what the market landscape looked like. We then moved on to see how the agent generative AI has evolved from a rule-based system into a generative AI world. Then we discussed about the healthcare integration challenges. We understood what a digital age patient is, what are their needs, and what are their expectations. We also discussed in detail about what an agentic AI is, how an agentic AI is different from a traditional chatbot, how an agentic AI can perform actions on behalf of uh, a patient or a customer. And we discussed about the philosophy that we do in creating an ethical AI employee, wherein we identify tasks, we define personalities, we map skills, set guidelines, and we apply business logic. So I've already in depth go through that and how create different agentic AI for different verticals. And then we discussed about the use case for digital age mothers, where we discussed about the bum's core capabilities, how it manages appointment, how it supports 24/7 care support for maybe the new age mothers. And also we discussed about the smart integration that bump has done and how it changed and transformed a patient journey. So essentially what we have done here is we have transformed the patient's journey to a more smoother, unified, and uh, joyful journey. So that's what's happened here. Then we discussed about the security and compliance framework that is required for an agentic AI in healthcare. We discussed about different privacy technologies. We discussed about ethical AI and what an ethical AI implementation in healthcare would require. We discussed about the human-centric AI design principles. Then, finally, we moved on to the technical architecture, where we discussed about enterprise-grade architecture, model lifecycle, and how an integration into the system would look like. We also discussed about how we could track the performances and what are the performances required, and what are the success metric for a agentic AI implementation in a healthcare. And finally, we had a glimpse of what the next generation of healthcare technology could look like, and the evolution of AI models into the future. That also we discussed and highlighted the certain areas where academic and industry collaboration would fasten the entire process. Yes, so that will be the session. Hope it helped and it gave an idea of what an agentic AI in healthcare through real world examples and our implementations. Feel free to ask any doubts or any queries. Yeah, so that will be it. Thank you.
Thank you, Mr. Neeraj. And if any participants have any questions or doubts, or you need any clarification, please ask. Yeah, I think that there is no questions from
Yeah,
the
thank you so much. Yeah.
Participant side. So I thank you on behalf of KMEA Engineering College and Department of Computer Science and Engineering and all the program coordinators of ATAL FDP. I sincerely thank Mr. Neeraj Manoharan for the wonderful session, and he mainly focused on the AI related and the industry, how it's working in the industry and healthcare system, what are the challenges they faced. So it's an informative session, and he also explained the traditional chatbot versus agentic AI. So those information is very helpful for the faculties or engineering college faculties. They are not that much aware about the industries, what is happening in the industries. It's a nice talk, and wish you all the best, Mr. Neeraj Manoharan, and thank you once again for your delivery of these lectures. Thank you all.
Thank you, Rafiq. Thank you so much. Yeah. Thank you.
Okay, I welcome back to all to 30th section. In this moment, I am so happy to invite Mr. Shihabuddin Pathanay to handle 30th section of FDP sponsored by AICTE-ATAL Academy. It's our great honor and pleasure to welcome a visionary leader and change maker, Mr. Shihabuddin Pathanay, an inspiring educational reformer, leadership coach, and founder of Hash Future School. Through his pioneering AI first approach to learning, he is reshaping the future of education, making it more meaningful, accessible, and affordable for all. Under his leadership, Hash Future School has gained both national and international recognition, including prestigious Best Innovative School Award at the World School Summit. We are truly privileged to have him with us today. Please join me in giving a warm welcome to Mr. Shihabuddin Pathanay, sir.
Yeah, good evening, everyone. Thank you very much for this opportunity. Unfortunately, I'm facing some issues with my camera. So it's going though it is working in the initial stage, it's going dark. So I hope that is fine, right? Okay. So I thank the management and the faculty members of KMEA Engineering College and ATAL Innovation and AICTE for giving me this opportunity. Hope I am audible, right? Am I audible?
Yes, sir.
Okay, fine. So can I share my screen? Okay, fine. I have got the privilege to share that. Okay. My screen is also visible, right?
Yes, sir.
So I'm really glad to hear that this is the 30th session. So you might have already experienced great sessions from industry experts and the real AI practitioners all across the world during the last 29 sessions. So anyway, I got the topic, the need for ethical, reliable AI tools in real world applications. Actually, we are living in a world which is changing each and every moment. So we need real great systems which can solve a lot of problems that humanity is facing right now. And AI is making it possible. So whatever was just a story maybe 10 years back is now becoming a reality. So we are really experiencing that. AI is creating a lot of videos or a lot of generative contents in total. And also, AI is also creating some humanoid robots and building some real world applications wherein we are experiencing that a lot of problems of the somebody who is a blind or somebody who is paralyzed is able to walk, right? So such kind of applications we are seeing on a daily basis. So maybe these are not in the production stage, but we can experience these in the labs, and some are getting even the medical board approvals in the US. For example, Elon Musk, the brain chip, also got some kind of approvals from the US government. So these kind of real world applications are really happening. And in some particular sectors, this is happening in a slow pace. And we need to actually speed it up so that humanity get the advantage of generative AI and other robotics and other stuffs in those fields, because these are really important. So to start with, I'll start with education, which is my area of expertise. So thinking about education, I started exploring because I am a computer science engineer by profession and by degree. So I started exploring about education 10 years back. So when I have 4 children. So when my two elder children were in school, so I thought of like finding out some solution, because they were still following the same curriculum which I was following maybe 20 years back. And they were really struggling with that educational model, because they were not able to accommodate with that system wherein they need to learn everything. They need to learn everything by heart in a rote learning model. So I started exploring different solutions that are available in the world. So I came across a wonderful solution in the US, wherein they were following the computer science first approach. So they started this revolution in the early 2000. So 25 years back, they already started a computer science first approach, where in India, we were still following the science first or the max first approach. So I started exploring about education, and when ChatGPT came into existence, or when the generative AI got released, actually we got the first hand opportunity, because we were actually doing a lot of experiments in education, right, starting from the computer science first approach. So we got the opportunity to experience generative AI tool in education. So when the New York City schools were banning, were going behind banning the AI, using AI, generative AI in education, we were actually going ahead or going in hand with the system. So we allowed our students, because in the meantime, so after experimenting with my children, we started a school system called Hash Future School, wherein we were following all the technology first approach in education. So we were willing, and our students, our community was willing to actually adopt the AI first approach in education. So we were one of the world's first school which experienced ChatGPT, the use of ChatGPT in education. So later after 6 months, I think New York City schools raised their ban. And they came back to the realizing that this is the reality, AI is the reality, and we need to actually adopt AI in education. But when we look back into many of the systems, or when we go deep into many of the systems that are prevailing in our area or in different parts of the world, they are still skeptical about the usage of AI. They still doubt that the traditional examination model, the by heart model, is still required. That is the claim that many of the educational institutions still make. And that is a wrong thing to do in a world where we are actually experiencing the revolution of AI. And generative AI, for to be specific, the power of generative AI. So we don't know what is going to happen, maybe in another 5 years' time or in another 10 years' time. But there are predictions from different technocrats like Sam Altman of OpenAI. Like, he is claiming that the colleges will shut down in 15 years. The colleges will shut down in 15 years. So even at that time also, while hearing this also, we are damn sure that the systems will exist. But as per my viewpoint, the systems will exist. The system will not get, will not get extinct. But the people who are adopting AI and people who are getting out of the system will be far successful. Maybe that may be less than 10% of the total crowd, but they will be far ahead of the 90% of the crowd who is satisfied with the present system. So, talking about the revolution or the use of AI or the ethical AI in a particular field, I would always give emphasis on educational part, because this is an area that we need a lot of change, right? We need a lot of change because this is a system that evolved with the industrial revolution maybe 250 years ago. And it created a kind of culture wherein we have to bring in some people wherein they'll have to do some 9-to-5 jobs, office jobs. They'll have to follow a particular model wherein people are modeled in a particular fashion, wherein everybody learns in the same fashion. Everybody is cultured in the same fashion. But that doesn't bring the kind of innovators and the thinkers and the problem solvers in the world. The people who are really researchers or the thinkers or the innovators of the real world are the ones who came out of the system and questioned the system. Right. So we need somebody who is fashioned in a particular way. We don't want somebody who is fashioned in a particular way, but we want everyone to experience the personalized educational model. So we started exploring about education, and we found that it is a 2.5 trillion USD industry all across the world, maybe more than that. Okay, so the traditional schools, the publishers, the tuition and the entrance edtechs, and the teachers and the content creators and the value-added service and many more systems actually depend on the present education system. But keeping it aside, we need to think in a different way. Actually, educational systems are not designed for these people. This is the reality. Educational system is never ever designed for the traditional schools, the publishers, or the tuitions, or the entrance edtechs. It is actually designed for the students. We have forgotten that real fact of education. It is actually the students who need to benefit out of the system. So this is what I have found out. The system has already gone far ahead of the reality, far away from the reality. The system is actually going behind the teachers, the publishers, the traditional schools, the colleges, the universities, and other stuffs. But that is not going to solve the problem, because here there is a real problem. We might have heard about Benjamin Bloom, right? We might have heard about Benjamin Bloom, who has brought in a great taxonomy in education, Bloom's taxonomy, which many of the modern schools follow, the IGCSEs and the IB schools follow, right? And there, Benjamin Bloom devised this Bloom's taxonomy in the early 1960s. So from that time, in the early 1980s, he came up with a theory where he told that there is something called Bloom's 2 sigma problem. Bloom's 2 sigma problems clearly state that every child will excel. Each and every child will excel. There is nobody who is going to be somebody who is a backbencher, who is somebody who is in the bottom list, or who is somebody who is a failure in the system. Only if we are able to do something different, only if we allow them to master in a particular subject. We should not actually give them all the subjects. Like, we should not give them a lot of basics. So we always claim that we teach a lot of basics, and we actually fill in a lot of contents in the education system. But that is not the real way things should be. Somebody who is going to experience the real education should get an opportunity to master education in a different way. He or she should get an opportunity to master a particular subject. Maybe, if in other words, we can say that call it as personalized education. So that is what is possible with AI right now. Because in order to give somebody time to master a particular area we need to actually give them some particular kind of care, give them some kind of contents which change on a daily basis. We should not ask them to just follow some simple books or just follows a particular pattern. He or she may require contents to master a particular area. We need to have contents that caters to the specific need. That is one part. Bloom's taxonomy also point to another thing, wherein if somebody is getting a personal attention, it's about getting a personal attention. One is about the mastering of the topic, and another is about getting a particular personal attention. If somebody is getting a personal attention, he or she is going to get another 2 sigma development. So if it is on mastering of the subject, if he or she is getting a 1 sigma improvement, maybe that is equivalent to around 80% of the improvement in the classroom. But when he or she gets an opportunity to personalized education, they will excel among the top 5% of the classroom. They will excel. So whatever you call them right now, if they are backbenchers or somebody who is not good in education, somebody who has got a learning disability, they will get an opportunity. If they get a personalized care, they will get an opportunity to excel in the top 5% of the classroom. But that is not possible with the traditional education or the model that we see right now with colleges and schools. Why? Because in a classroom of 60 students, we may actually we may be actually able to deploy only 1 teacher, right? So that is not going to solve the problem. So who is going to solve the problem? AI is going to solve the problem. AI is going to come up with a solution, come up with some kind of real tools that give them personalized care based on the progress of each and every learner. So that is what we experienced at Future School, or the systems that we researched about, because we are not the only school which is solving this problem. Okay, we are not the only school which is solving the problem. There are Ad-Astra schools in the US started by Elon Musk. There are Astronova school, the Up school. There are different communities, the democratic schools, and different forms of schooling which solve this problem. So this is about AI-driven learning tools. So this is about giving them, each and every child, a personalized care in education. So at Future School, what we do? We create artifacts. So for your reference, you can actually create artifacts in Claude AI, right? In Anthropic Claude AI, you can actually create live simulations. So rather than going behind a video, or rather than going behind a game which is already designed, if you find that a learner actually needs some special care, we can actually create a real-time simulation. We can actually create a real-time 3D simulation or a game, so which can support that particular learner. So that is about personalized education. So it's like cooking a dosha, or like we always say, right? So we actually prepare a dosha when somebody is ready to eat. So here, a learner can actually be given some different methodology if he or she is not able to follow some methodology which we have already designed. So this is one part. So we can create live simulations. We can create live tutorials of we can create easy methodologies. So this is one part of the tool. We might have already experienced, we might have used ChatGPT, or we might have used the study mode that got released last week. So there are other systems like Notebook LM. This is one part. This is some system which is already created by a company or a corporate, but they give you some other opportunity. So this is another opportunity for us to think about something we can create, or think about something we can actually create out of the system or the SDKs which is already available. So this is a damn easy. So the solution, so everybody asks us like, how you create such a system? What kind of training you give to teachers? So we always say that we don't teach. We don't teach. At Ashbridge School, we don't teach, because all the best system what we have found is like, there we did not teach anyone. The students learn, because the students actually get an opportunity to experience something which they like, which they love, which they are really interested in, where they can find real-time outputs. They can experience real-time outputs. They can go to a marketplace and they can simulate a sales, or they can simulate a marketplace, and they can even sell their product out of that marketplace. So that is the kind of opportunity, real-time experiential learning. So it's not about, so whenever this kind of discussion happen in the education sector, people always say about a robot coming to a classroom and teaching. This is actually costlier. And this is not going to solve the problem, because the students may get bored after 2 days. So what to do with that investment? So don't invest heavily on any tools. What do you need to do? Take the free version, or the academic version, or the educational version, which is available free of cost. So what we do, we take this kind of tool, we collaborate with Gemini, we collaborate with ChatGPT, we collaborate with Canva, we collaborate with all the companies. That is another opportunity that has opened up in this particular era of artificial intelligence. So this is another opportunity that we need to tap. So this is how we need to use, because we should be wise enough. To, while investing for a product. Don't go behind costlier tools. Don't go behind costlier, applications or the robots, because that is not going to solve the real problem. So if you want to solve the real problem, what do you need to do? You need to stop teaching. You need to access this kind of tool. Ask the students to come in and ask them to co-create, communicate with them, like, we are going to co-create, or we are going to co-learn. We are going to learn together. So just forget about you being a teacher, or you just forget about you being a doctor or a professor in that particular area. Just forget about that. Start relearning, unlearning and relearning. So this is one of the best solutions that we built with AI at Ashbridge School. And this is how we need to actually design education in the era of AI. This is what we need to do. It's not about supplementing some kind of tools or some kind of solutions, or adding 1 or 2 modules. It's not that. The solution should be complete solution, a new solution that we need to actually devise. This is how we can actually, this is how we need to think about bringing AI in education. So this is one area, AI-driven learning tools. This will make the learning process really something that the students will love. So once they start loving the subjects, or once they start loving the topic, they will learn on their own, they will create something on their own, and they will be real-world innovators and researchers. And this is one thing that we emphasize at Ashbridge School. And another is about the assessment systems. So coming back to the assessment system in our education system, what is happening? We are following the century-old assessment systems of exams. We still claim that the students need to by heart all these stuffs. They'll have to do all these kind of projects. They'll have to come up with all these kind of assignments. And they should not use ChatGPT. They should not use generative AI. This is what we claim, right? So we always, whenever we want somebody to submit that assignment, what we say, don't use ChatGPT. It's like what we did maybe 20 years back. We banned calculators and the computers from the classroom. And what happened? Our students went way behind the students in the US. Though we claim that academically they are good, They are not somebody who is creating a solution for the real world. That's what we witnessed in the last couple of years, wherein people from US and China came up with great solutions in LLMs and generative AI and robotics. What we came up with was the learning modules for that. That is another irony. In India, we started developing courses to teach ChatGPT. We started courses to teach artificial intelligence. We came up with brilliant 4 or 5 streams of computer science, AI, robotics, data science, and some other stuffs. Only because we didn't actually understood the power of artificial intelligence. We failed in that particular area. So coming back to assessment system, we followed a wonderful model. We actually created a simple project in Cloud AI, or maybe custom GPT in ChatGPT. And maybe related to that, we have gems in Gemini right now, right? So we just created a system. We asked the AI system, we need to assess our students, but not on marks. We actually need to assess them in a different way, what to do. So it came up with a brilliant solution. AI came up with a brilliant solution and told us, like, we will evaluate them in critical thinking skill, problem solving skill, creativity, analytical skill, and team leadership and management, and blah, 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 a lot of stuffs. So this is wherein we were able to build a great system, wherein we are able to evaluate our students based on their activities rather than their submissions. Not only their submission, the kind of involvement they give in each and every layer of their education, or in every layer of this assessment system, or the assignment submission. So we were able to evaluate the students in a better way. So we started discussing what we can do in like fostering their creativity, what we can do better in in bringing them some kind of skill in critical thinking models. So that is what makes a new age learner successful, right? So we were able to build assessment system, and we are improving the assessment systems on a daily basis, wherein everybody is struggling behind the exams and the kind of university certificates. We always say that we always ask our students to create their own portfolios. Don't just wait don't just wait to get a certificate. Rather than that, they can create their own portfolios, and maybe next day, maybe after 1 year, they can sell it to a company. They can create a demand. They can ask, I am proficient in so and so areas. This is what my portfolio says. So what do you need to do? If you need to hire me at the package that I say. I don't want your job. I don't want your package that you have already designed. I need my own package. I will demand. That's what is happening in the recent hiring of Meta, right? So Meta offered $150 million US package to an engineer. He rejected that. And the next day, Mark Zuckerberg went to his apartment or office and offered him $250 million US. So Mark Zuckerberg himself went and requested that guy to be a part of the Meta team. So that is the power of social media, and that is the power of artificial intelligence and the present day world, right? So that's how things should work. And Elon Musk has rightly claimed that he need somebody who to be a part of his new project, but he don't want somebody who he don't care which school they have gone to, and he have further stated that I don't even care whether they have gone to school. Right. So that is the kind of opportunity. That is a way we need to think about while thinking about educational system in a new age era, in the era of artificial intelligence. So we can assess the students in a better way. So coming back to the access and equity, this is another critical point. So every education should be accessible to all. That's why Indian government has kept it as a non-profitable entity. So Indian government has got clear guidelines of where the education should be placed. It should be non-profitable, right? So it should be accessible, and it should be accessible to everyone. So that is possible with this advancement of online technologies and AI. So people always claim that online education will not work. It will work, and that is the future. It will work, and it should work, and that is the future, right? So if everybody need to have access to the right education, the best education, What we need to do, we'll have to go online. So that's what we do at Hashmishu School, because we don't learn from somebody who is giving a course. We actually learn from the creators. So there is OpenAI Academy, which is available free of cost. So whenever somebody discusses me with about education, I always say that the best education happens for free. The best education happens for free. So people always say that in Kerala, in government schools, we give education for free. And in India, we always give education for free. But there is a cost. What is the cost? Actually, Kerala government claims that it pays 25 lakhs. It spends 25 lakhs to get somebody graduated from the government system. So that is a spend, right? Maybe there will be a spend, but what we need to do, we'll have to access everything which will come to you for free. The technology, the creators are actually teaching this kind of technology. So we need to actually allow our students to access all these kind of things. So that's what we actually brought forward when we thought about bringing in some kind of changes in education using AI. We followed this AI first approach, wherein we told our students, if there is an AI to do something, use that. If there is a calculator and a computer to do something, use that. Don't go behind something that the computers and the calculators can already do. Don't go behind rote memorization. Don't go behind by hearting stuffs. Go behind something wherein you can use these kind of AI tools and the technologies and take your skills to the next level. So even if that is a child of age 10, we actually give them access to AI. So that's wherein these ethical practices and responsible AI come into place. Say, for example, if we are denying all these kind of tools and technologies to the students and telling them not to use ChatGPT for research, not to use Grok for research, and come up with your own, fantastic ideas, and they come out of the system after 25 years, realizing that all these systems have changed. So that should not be the case. So even if he or she is of age 10, what we need to do, we'll have to teach them how to use these systems in a constructive way. All these concerns about AI, all these concerns about ethical AI, responsible AI, everything is centered about our concern. It's only just a concern. Once we start giving them opportunity to use it in a constructive way, once we guide them to use these technologies in a constructive way, what is going to happen? They are going to come up with wonderful creations. Human beings has got a great power. They know what is bad and what is good. So the only thing that we need to do is we'll have to give them some kind of opportunities to experience these kind of systems, learn what is ethical and what is unethical, learn what is good and what is bad, learn what is constructive and what is destructive, and give them opportunities to explore these kind of things and take it to the next level. Only that is going to solve the problem. And believe me, there are great curriculums designed for this. But unfortunately, that is not there in the educational system, because the educational system is busy fixing the basics, which are not the basics of this AI world. Educational system is busy fixing the system which is not the basics of the real world. They are behind teaching the multiplication table by heart. And they claim that Elon Musk and Sam Altman has already told that it is really relevant to learn mathematics and physics in this AI era. I'm not claiming that it is false, but that is a different mathematics and that is a different kind of physics. It is not the one of by hearting the multiplication table, the one being a fast, being somebody who is a human calculator. That's not the math. The math of LLMs and the math in the era of LLMs and AI is different. So we need to actually take the help of these kind of systems and make the education accessible and equitable to all. So that's where the system becomes ethical. And there are unethical practices too. We can't actually deny that there are people who use everything for good and bad, even the books. Even there are good books and bad books, right? So that is not only the case with AI. Ethics doesn't only tie up with while we're discussing about AI. It's about when we discuss about anything, whether it be a book or a novel or a cinema or anything, ethics ethical and unethical practices are found everywhere. So it is the user of the system who need to actually think about this and bring an ethical practice in that. So don't worry about being ethical or unethical. The only thing is that we'll have to create some ecosystem wherein our students and the children of this new generation get the opportunity to experience all these kind of things. And for me, my last 10 years and with the advancement of generative AI for the last 4 years, I have seen tremendous improvement in each and every child who is there in our system. Because sometimes people claim that many students have got learning disability, and they go behind therapy, spending lots of money and a lot of worries, because the parents are really worried, because when the time of exams come, it is the blood pressure of the parents who is getting shoot up. And I always say that take it in an easy way, take it in a simple way, because if you think in a simple way, you have a solution. You have a solution, and AI is here to help you out. If somebody has got a learning disability, I always say give them some companionship of an AI chatbot, maybe AI Copilot, maybe Microsoft Copilot, or ChatGPT or Gemini. If you give them this kind of support, actually they will talk to the system and they will overcome these kind of learning disabilities and reading issues. Because now the parents are really not giving them time. The parents are not speaking with them. If you take the case of infants, even at the age of 2, you are sending them to school, right? Even at the age of maybe in the infancy itself, even when the first day after birth, if you start a course, actually the parents are willing to enroll their students in this kind of systems. But we actually start education at the age of 7. We say that the students need not go behind these kind of kindergartens and play schools and other stuffs and waste their time. Let them think in an open way. Let them explore the world. And what is the result of that? They explore using these AI tools. They explore using the videos that are available, and they come up with excellent skills in mathematics, science, and research. Even before starting the alphabets, even before learning the basics of math, they come up with excellent solution. That is what humanity really need. So in the field of education, we have great applications, provided we are ready to think in an open way. This is what we need to actually think in an open way, with an open mind. So we need to actually start questioning. We'll have to enable the new generation to question things. We'll have to allow them to question. Because when we speak about the prompt engineering, I always say somebody come up with a course of prompt engineering. I always say that if you can question a system, there is no need of prompt engineering. So that is a fancy term. But if somebody is able to question a system again and again, that's where you get great results, right? So if you are developing a software using Cloud Code or some other like some other fun, wonderful AI tools, generative coding tools, what is going to happen? If you question in a better way, you are able to build a great design. You are able to build a great application. So that's where AI comes into practice. Then this is the only thing that we need to be concerned. Don't be concerned about anything else. Concerned about, like, while giving this kind of system, you need to actually guide them to use in a constructive way. So that is not only the problem with the new generation or the new generation learners. That is a problem with an older generation too. That is where you need you see a lot of people actually addicted to the system. The new generation is so in my experience, the new generation is not actually addicted to the system as the old generation, because they are technology native. They know how to use it in a constructive way. And if they get an opportunity, they will work wonders. They will come up with great startups. But for the old generation, I don't know what to do with them, because they don't know, because they are somebody who came from who are actually aliens into this new world order. And they don't know, they were not coached to use these kind of systems in a better way, and they have the problem. So we need to solve the problem in each and every area, because as the Singapore government is solving, the Singapore government is actually planning to upskill everyone above the age of 40, because that's where a lot of opportunities, we will miss a lot of opportunities. Okay, so we'll move to another sector. So from education, because that was one area I can actually speak a lot. Maybe if I get around 5 hours of time or 1 day or 2 day, it may not end, because that is one area I am really experimenting and I'm seeing great results, and I'm actually collaborating with a lot of people all across the world for building such a solution, which is because that solution is really required in the new world order. So coming on to healthcare, we might have already listened to some speakers, because there were brilliant speakers in the list. So we might have already came across this news wherein China has already opened the world first AI hospital with 14 artificial intelligence doctors. So this is one area we need to actually clearly bring some solutions in India, because we don't have great doctors in India. Even if we have doctors, people don't have accessibility to doctors in many parts of India. All right. The patient to doctor ratio is actually, the gap is huge. So we need to actually solve that problem. So in order to solve that problem, AI is going to here to help you. But you need to think in a different way. That is not about building great robots. It's not about like solving the problem we already have. Because we are really expertise in solving the problem we already have. And of course, I agree that we need faster solutions. So something that is which is taking maybe a year to find a solution. Now using these kind of technologies, the ChatGPT and the generative AI and other stuffs, we can actually find great tools wherein we can actually diagnose a problem. Maybe at the initial stage itself. Maybe we also have opportunities for somewhere we can actually prevent the disease from happening. We can actually monitor the person. So the company, the kind of chips that are getting built, the Neuralink chips, are actually solving a lot of problems. And there are similar companies. You can see a lot of companies coming up with a great solution. And in healthcare also, we need to actually think, whenever we think about AI, we need to think about something which we need to actually really examine on that. What is that? So people always claim that human doctors cannot be replaced. I really agree to that. But there are 3 major things that a human doctor do. What are they? They diagnose a disease, they prescribe some medicine, they actually perform surgery. So actually, AI and robotics have already done this. All right. So in terms of diagnosing a disease, actually AI is far better in the diagnosis area. Right. So even if you are somebody who is facing some health issues, you go to a doctor or you go to a hospital, they'll give you 3 different options. One is some diagnostic option using a human, using a doctor or a human, consulting a human being. Another one is using the kind of the older diagnostic tools like the ECG machine, the other kind of machines that we find in a hospital. And another one is the robotic surgery or the robotic diagnosis. So which one will you prefer? Which one will you prefer? If somebody is here, you can, if out of the 3, which one will you prefer? If you go to a hospital, you'll always prefer robotics, right? You'll always, even if that is a costlier affair, maybe you'll have to spend maybe 50,000 to 1 lakh extra for that particular surgery. You will always prefer a robotic surgery because you know that that is going to be accurate. Right, that is going to be a great solution, because if you don't believe in a human doctor, maybe if you frankly say you actually don't believe a human doctor, only because you know that the system is much more accurate, right? Because it has got the power of maybe the lakhs and lakhs of doctors who have already come in from the very first day of the human generation, right? So it has got that knowledge. So that is where we are actually going to solve this problem with AI. So with artificial intelligence coming into place, the diagnostic accuracy is going to be better. So that is going to solve a bigger problem of pandemics. That is going to solve a bigger problem of the genetic diseases. That is going to solve a bigger problem of many issues that human beings are facing right now, even in the case of cancer, even in the case of some other dangerous diseases. Actually, human beings are trying to solve all this problem in a better way. So here also ethics come into play. So what is ethical and what is non-ethical, actually, we can't define at this stage. We can't define, but we can be responsible. We can be responsible because before using this kind of tool, we'll have to do the kind of research. We have to do the kind of research in different animals and other protocols and all, but that is getting a faster pace right now. Because take the case of COVID pandemic. So if it was the case of Spanish flu, it took around maybe more than 10 years to find a vaccine. To test that and come use it in the human beings. It took around 10 plus years. But think about the case that happened in COVID pandemic. It took only around 6 months time, right? 3 months or 6 months time. The vaccine was discovered, the vaccine was tested, and the vaccine was given all across the world. So that is the kind of solution that is going to get built in the era of artificial intelligence in healthcare sector. So maybe somebody who is practicing in healthcare system can actually give you some wonderful results in that. So coming on to some kind of comments that have already come in the chat box. Behind the robotic surgery, there must be the hands and brains of a human. Yes, great. So that is one point I am going to discuss. But the effort that the person is going to put in that area is going to be less. So the humanity is going to witness something which we have not witnessed anywhere in the history of the mankind. So we don't know what is going to happen. And the systems which we see as robotic surgery in our nearby hospitals, maybe that may be controlled by a doctor in the US, but the system learn in a faster pace. Now, the new robots actually don't follow the machine learning pattern. They just watch videos. They just watch what is happening all across us and they learn. So that is some kind of change that have come. So if this system get advanced in the medical field, what is going to happen? So somebody can be like, we have already seen driverless cars. We have already seen teacherless classrooms. So these kind of systems will evolve and these kind of systems will get better. And believe me, so whenever we discuss about these kind of systems and practices, people always say that it is going to be a threat to humanity and we are going to lose the opportunity. But that is not going to happen. That is not going to happen. Somebody who is going to use the system in a better way is going to become a master. So that's what I told while discussing about the 10% of people, the population who is going to use the system, and the another 90% who is skeptical about this and are staying away from the system and are following the older system, the legacy system, claiming that that is going to work. What happens to them? According to Yuval Noah Harari, they become useless. So who is Yuval Noah Harari? He predicted all these changes that is happening in this generative AI sector maybe 15 to 20 years back. Even he can't predict what is going to happen in the next 20 years because he is helpless. And he claims one thing clearly, like he always says that if you are not somebody who is adopting AI in each and every field that you work in, or that you are engaged in each and every field, it may be education, healthcare, governance, or any field. If you are the one who is not ready to use the kind of systems, what is going to happen? You are going to become useless. And the person who is going to use is going to become ultra rich or ultra wealthy, or we are actually going to witness a bigger gap behind human crowd, the kind of people. Now we can see there is a narrow gap between the upper class, the middle class, and the lower class. Okay, in terms of the wealth or in terms of the facilities they have. But this is going to widen up. This is going to widen up. Okay, so in the field of healthcare, we can see we are going to witness a lot of diagnostic accuracy. And we are actually going to witness a disease-free world. I'm not claiming that that is going to happen, but that can happen. Because if you check the history of humanity, what was the situation maybe 100 years back? There were a lot of pandemics. Though we have experienced the COVID pandemic recently, there were a lot of pandemics which resulted in the extinction of a lot of communities in different parts of the world. That is one part. And human beings were experiencing a lot of poverty. So with the advancements of the agricultural technology, not only AI or the generative AI, but the AI actually existed maybe with the invention of the computers itself. AI is not a new term. Artificial intelligence is not a new term. This term was actually coined when human beings actually started using computers or started inventing computers. So this was there. So with the advancement of technology, actually poverty was eradicated to a great extent. So in the similar way, we are actually going to experience a disease-free world. Right. So a lot of experiments are happening in the Silicon Valley where people are actually invested a lot in in retaining their youth. So each and every 2 years, somebody is clearing the entire system and are trying to bring in some kind of rejuvenation program wherein they are actually claiming to retain their youth. Okay, so those kind of experiments are happening. So we expect that we can experience a disease-free world. So this is another area because we have got a UN citizenship curriculum wherein our students learn a lot of global citizenship curriculum, and they learn a lot about UN SDGs, Sustainable Development Goals. So this is one area wherein the UN has put one area wherein we will have to give better medications, and we will have to come up with a poverty-free world. So this is another area wherein the healthcare sector is going to excel. And this is what. So that answer to the previous question is like human doctors will exist. They will not become extinct. But the kind of doctors that we see right now, the people who clears an MBBS or an MD or somebody who has got 20 years of experience or 40 years of experience is not the one who is going to excel in who use AI in a better way. So one of my friend Abhilash, who is going to present a paper in this seminar itself, he is actually building something called an India AI, where he is bringing ChatGPT kind of experience to doctors even during the surgery. So I don't know whether the session is over, but you might have you will get an opportunity to hear from him. So that is not one experiment that is happening. There is an experiment that is happening all across the world, wherein people are looking forward for solutions using AI, because AI can actually solve a lot of problems. AI is actually solving a lot of problem with the new generation. Actually, I recently read that a 15-year-old homeschooled child actually solved a bigger mathematical problem, which was a headache of all the mathematicians for centuries. He solved that problem at the age of 15 using AI. And the classical cat cutting problem, that was a big problem which was not solved for centuries. And a group of youngsters were able to solve that problem. So those kind of solution, and people are now depending on ChatGPT and for diagnosis kind of purpose, right? So this is going to be democratic. Every field is going to be democratic. That is another advantage of artificial intelligence. Every field is going to get democratic. So don't believe that if you have got these many years of experience in education, if you have got these many years of experience in medical field, you are the master in that. Don't ever think that, because somebody who knows how to use the AI tools in a better way is actually going to get an upper hand on each and every person who has got an expertise in that particular field. Okay. So another one is the finance sector. So another claim from Sam Altman, the co-founder or the founder of OpenAI, is that the global interest rate will be -2%. Now it is around 12 to 20%, right? So you will get money from the bank. Okay, so does that sound interesting? You are going to get money from the bank. So there are some discussions happening around all across the world about universal basic income and the universal I forgot the terminology used by Elon Musk. That is something higher than that. It's not about the basic, so it's about universal bigger income. Okay, so something like that. But this is going to happen. So this is something that excites us because we are actually suffering in the hands of banks because we were not taught about financial management in our schools or colleges and even MBA classes. So once after completing the MBA classes, we find that we don't know anything about money. We don't know how to create money. We don't know how to manage money. And we find ourselves to be somebody who is working 12 to 18 hours to repay your EMIs. So that is AI is going to solve that problem. Right. So AI is going to be a great guide in finance. So it is going to help businesses to plan their finance in a better way. And Elon Musk has already given instruction to his team in X, formerly Twitter, to create a system so that the banks will be closed in another 2 years of time. So maybe even if that doesn't happen in next 2 years of time, believe me, it is going to happen in next 10 years of time. So whenever I discuss about Hashwich School, people always ask me about you are a single person or you are a part of different communities, but what happens if this cannot be done by you because this is something revolutionary that you are going to build. So if you are not able to do as a single person because there are institutions which has got the legacy of 400, 500 years, and they may actually reject you or oppose you. So I always say that this is a thought process that evolved in my mind, but there are hundreds and thousands of people thinking about the same. So if somebody is not building a solution, don't think that that solution is not possible. Somebody else may come up with that great solution. Okay, so thinking about AI bringing some change in finance, what we need to understand is that it is going to create a world order wherein we have a kind of community wherein everybody has got access to great systems which can act as great guides for them, which can actually support them in managing their finance. So coming back to businesses, because previously whatever this Deloitte and PricewaterhouseCoopers were doing, now you can do the same in your business, a small business or a startup. You can actually plan about the unit economics in your business. So that is the power artificial intelligence has brought in. So tomorrow, if I need to take a decision, I can actually take a decision of scaling up or scaling down, maybe in 1 day's time. I need not wait for all the consultation or all the financial reports or the market analysis that comes from these people, because there are deep research AI agents like Manus AI and Perplexity research or the Grok deep research or the Gemini deep thinking models. So these kind of systems are actually accessible for me from my desktop or the mobile. So I can build great systems for that. That's where we also need to think, because using AI and your domain expertise, if somebody is in the financial sector, what they need to do, they should actually come out of their degree point. So somebody who is a CA, chartered accountant, should actually think in a different way. Think like building a new systems for supporting small businesses or the kind of helping the people on their personal finance. Right. So we are going to experience a world wherein everything is getting democratic. Everything is getting democratic. So that even the Perplexity came up with recently with a great feature. What is that? You can actually get the live data from Sensex. All right, the stock exchange, and you can actually analyze the live data and take decisions. So this power is coming to each and everyone. be it a 10-year-old child, or be it somebody who is expert in this field for 80 years, they are getting the power of artificial intelligence. So never ever claim that we are human beings, we don't need the support of artificial intelligence, we'll manage everything on our own. We will always trust the legacy system. We find that AI is unethical. We find that AI is irresponsible, and don't move away from the system. If you are a human being, take the help of AI. Take the help of systems that are coming up in place. Adopt to that situation the very next instant. Failures can happen. Today itself, one of my friend shared me one screenshot saying that ChatGPT is down. So what to do with that? ChatGPT is down maybe for 5 minutes. Maybe even if ChatGPT is down, maybe we have other better systems, and the systems will again evolve. So coming on to the financial sector, take the help of AI. So somebody recently was able to solve all her debt problem. She was actually facing a financial problem, personal financial problem. She actually got an opportunity. She got an advice from ChatGPT and solved the problem. So if you are facing personal financial challenges, if you are somebody who is struggling with the advices of the conventional CAs and the financial consultants, create a custom GPT telling your scenarios and manage your system each and every day. Maybe you can create a sub-agent, you can create a finance agent, you can create a financial system of your own, you can take all the documents which is available with you, you can collaborate with other platforms, and you can get the knowledge from there. Build great systems which will cater your need. So that is one area that we need to actually address, coming on to using AI in financial sector. And we can actually, the financial systems can actually do great credit scoring with more data. So we need to be actually aware. We need to be actually, so if we are somebody who is having a bad credit score, so we can ask the support of AI to improve the credit score on one hand. And we also need to understand that we can't actually cheat the systems. Maybe somebody will come up with a better solution. This is human being on the other side. And the system, believe me, with the evolution of the advancements of artificial intelligence, human brains are also going to evolve. There is no pointing in telling that if artificial intelligence is doing so and so jobs, the human brain will become rote and human beings cannot think. Those are the claims of people who don't know what system is actually getting built. They are the conventional psychologists and the people who always bring in some kind of fear factor to the society. We need not actually listen to, we can listen to them, but don't listen to them and trust them 100%, because they don't know what kind of system is getting built. Right. So if you need to be somebody who is better in this AI era, what we need to do? We'll have to actually be someone who adopt the AI in our own daily life. We need to think about what AI, how we can use the AI in a better way. So the credit scoring area, because the banks are going to get a lot of advantage, or the governments are getting going to get a lot of advantage, and they are going to come up with great systems. Okay, and people are going to cheat the system again, and they will come up with a greater system again. So those kind of changes are going to happen. Okay, so we'll have to think better than the system. And coming on to the governance, this is one part AI is going to help. So this is where the governments and the policymakers and the politicians are actually cheating us. So I'm not claiming that everybody is cheating us, but the governments don't want the AI to come, because the system is going to be highly democratic. The system is going to be highly transparent. And the policymakers don't want these to happen. Okay, I'm not giving you any political statement, but believe me, the policymakers don't want people to think. The policymakers don't want people to get transparent information. That's why the educational system is not changing for decades or centuries. It's actually changing in a slow pace. That's why, because they don't want people to think. They don't want people to question. They want people to be in financial troubles all across their life. They want people to be in debt. They don't want people to be happy. If there is such a government where people want to be happy, believe me, people will start questioning them. People will start questioning the legacy system. All right. So this is another area wherein artificial intelligence is going to help us, the governance. So it is going to build a greater system wherein human beings has got greater facilities. We are going to get greater facilities. We might have already heard about the faster transportation mechanisms. We might have already witnessed driverless cars, but that is just the tip of an iceberg. This is not the change, because this is just a small change. Like Henry Ford already told, like if he could have taken a survey among people, what would be if he has taken a survey among people about what transportation mechanisms they need, people would have always told like they need a faster horse. But he didn't went to these people. He started about thinking something great. So he was able to build the diesel cars. Right. So that is something that is going to happen. We are going to witness a world order wherein we are going to see something which we can't even imagine. Believe me, such systems are getting built. Such systems are getting built, because whatever ChatGPT or the Gemini or the Grok or the Cloud that we see is something which they just released to the public. There are better systems in their labs which they are not actually releasing to the public. And these systems are going to build greater systems, maybe the kind of LLMs that we see right now, or the kind of chatbots, or the kind of the advancements that we see right now, may not be the right use case of AI. Because this is just, we are just trying to solve the problem that we face right now. Because there was a famous saying from Steve Jobs. Steve Jobs actually told one thing like, if human beings are actually going to invent something, they actually find the real use case after 25 to 30 years. So we haven't actually found out the use case of generative artificial intelligence right now. We haven't found. So it will take another 25 to 30 years, and the systems are changing in a faster pace, so that we can't even learn, or we can't even actually adopt a system. So a new system is coming up in place. So during his speech, actually Steve Jobs was actually citing the example of the invention of television. So after the invention of television, the sole purpose of that system for 25 years was just to telecast the radio shows, the traditional radio shows, which was already there, which was already happening. What they did, the new television systems actually started telecasting these kind of things, and they continued it for the next 25 years, because they never knew what to do with this television system. But we know now what is the advancements that the television system brought to our human the humanity as a whole. Okay, so this kind of artificial intelligence that we see right now is going to change each and every sector in a different way. That's what I see it in education sector also, because the change is not going to be something incremental. The change is going to be dramatic, which we can't even imagine. So come out of the system. So whenever you think about better system, come out of the system, think in a different way, execute in a different way, and come up with greater solution that the humanity really need. So coming on to the governance part, we are actually going to experience AI for smart cities. So we have already heard about the project of smart cities, wherein government has declared some cities as smart. And if you go to China, you are going to really witness smarter cities. Because you might have already seen some videos wherein China is well ahead in every sector, right? So they are thinking in a different way. They are building smart cities. And AI is going to be one area which is going to boost the kind of smart city culture that we are going to witness. So when I went to Day6 Dubai a couple of years back, I actually saw a system from the Russian government wherein they are actually using some kind of surveillance system wherein if they find a crowd of more than maybe around 1 million people, they'll be able to identify the person's face from that bigger crowd. Okay, so that is one part of the surveillance part. So thinking about the ethical side, actually, we'll witness a lot of misuse of the system by the government itself. So if you need to actually witness a change in the real change in artificial intelligence, please please be somebody who is going to think about something which you can build using AI technologies. Okay, so the smart cities, the smart governance and models are going to come in place, and policy simulations. So nowadays what happens? The government come up with a fancy policy. So one find a minister get an opportunity to hear from somewhere that somebody has implemented a policy in China and it has worked well in China. And then the very next day he will come up with a bill in the parliament and they will appoint the committee, and the committee will do some kind of sittings wherein mostly they will be discussing about their food and the travel allowances. And the system implemented will have a lot of loopholes. But believe me, coming on to artificial intelligence, we are going to get opportunity to simulate this kind of environment for a bigger crowd. So coming on to the simulation part, you might have heard about the Lane project in Saudi Arabia. So Michio Kaku, who is the chief architect of that project, Michio Kaku is one of the futurists, he's a futuristic thinker. And he is also somebody who is into the core team of designing that city, the vertical city, named Lane in Saudi Arabia. There was one video wherein he was explaining that they never tested any materials in the physical space. They never tested any material in the physical space. They just used AI simulations to test the materials in that particular project. So the similar way, we can actually use AI for policy simulations. We can get to know like what kind of issues has happened earlier in implementing this kind of a system like earlier. So these kind of simulations can happen. So believe me, a lot of changes are going to happen in governance, and this can help us to save a lot of money. This can actually help us to even to take great decisions without much failures and without people getting affected in an adverse way. And of course, this is our dream, right? So we always dream about something which can't happen. But believe me, maybe if the government is not going to stop the changes, the government is not going to block the changes in artificial intelligence. Even if they block, the system is going to happen, because the system of governance that we see right now has just evolved 100 years back. Just we are experiencing it maybe for around 70 years in India, and this will change because human beings existed here like maybe thousands or 10,000s of years, right? So this system was actually not there. So whatever we see right now may change. Even the governance will change. And we hope that there will be a correction-free governance, because people are going to analyze each and every data. This is a key part, because people get the opportunity to get access to each and every data, even if the government block, or even if the ruling party or the ruling government block it. We are going to get an opportunity to to experience all these kind of data and come up with great analysis of this data and question the government. So if we have a data in place and everybody has got access to right data, so this is a kind of environment wherein we can actually bring in corruption-free governance. So coming up, ruling ruling in the era of AI is not going to be the same that we have witnessed earlier. So we can't actually stop people from asking questions. We can't actually we can't actually hide something which is happening in the government or in the public sector. Okay, so this is another area that AI is going to play a greater role. And coming on to the scientific research. So with quantum computing and artificial intelligence in place, the scientific research is going to the next level. So I already pointed out some instances wherein we are able to solve some problem which was greater problem for the humanity for a couple of centuries. We were able to solve, and the scientific research is going to the next level. So it's not about using the deep research or the deep thinking models that we witnessed right now. They have got better models. Even each and every scientific labs have got better models, and they are getting assistance from these companies. Of course, the Anthropic research team is actually collaborating with the US government and different research agencies, and even the ChatGPT team, the OpenAI team is also actually collaborating with a lot of researchers all across the world. So if you go to their YouTube channel or their research papers, you will find that a lot of research are happening, but in a faster pace. So what took humanity all these years to learn? The power of quantum computing with AI is going to solve it in minutes. Okay, so we are going to witness a different world order. So we are going to find a lot of new researches coming up. So if you are somebody who is who has experienced the time of COVID pandemic, what is going to happen? We are going to witness a world wherein we have got more and more drugs and vaccines which are going to cure a lot of diseases. We are going to witness a lot of devices which will give you a lot of analysis about your body, what is happening in your body, solve some kind of problems which are happening in the the human population, and are trying to solve that. So you might have already witnessed the kind of pace with which the COVID pandemic, the COVID vaccine was actually discovered. And this is another big area, because we people are really satisfied with plastics. We use plastics on a daily basis, and we want the environment to be plastic free. We claim that we are somebody who cares for the planet. We have solar power generation at our home. We use solar cars, but we buy plastic stuffs. Okay, so plastic is one big issue that we are facing. But material science experiments proves that AI is able to come up with millions of new combinations and new particles. AI has right now, whatever system we have right now, have discovered millions of new particles. I think around 3 million or something around that. So those kind of particles are going to change the way that we create right now. Right now we create cars, we create computers, we create many stuffs, but they are actually adding to the pollution of the environment. But this is a kind of situation wherein we are experiencing a world wherein these kind of systems are actually coming into scientific research, and it is better than a PhD holder. Okay, or better than a university which has a lot of PhD holders. Okay, so this is a kind of systems. Even GPT-5 claims to be better than PhDs. Okay, so this is the power that everyone is going to get. So if scientific research is not just the game of scientific research labs, it is something that is coming to each and everybody's hands, using the power of systems that we have. So using the power of artificial intelligence and the new models, we will be somebody who is able to come up with greater solution, which can actually ease the life of human beings. All right. So material science is one area in scientific research which is going to boost up with the coming of artificial intelligence. But here another issue is coming up about the ethical usage, because the recent wars that we saw actually used a lot of AI weapons to actually target people based on their race, based on their community, based on their devices. So this is going to create another ethical problem. So the systems that we invent may be used for unethical purpose. Even the atom bomb was actually, the nuclear reaction was actually a scientific experiment which was done for the betterment of humanity. But what happened? Some system which is in bad hands, even good systems in bad hands, are going to be catastrophic. Right. So what we need to do, we'll have to actually educate human beings to use the system in a constructive way, to use the system in a better way. So that's what we need. The humanity need a lot of support in that, because using artificial intelligence, we'll have to use these kind of systems for a constructive growth of humanity. So for the constructive development of humanity and scientific research. So coming on to the astronomy and space research, human beings are actually, so even before the advancement of generative artificial intelligence, human beings were actually planning to colonize Mars. Now we will be able to colonize a lot of other areas or other planets and other universe and other stuffs, because our reach using this kind of artificial intelligence technologies, what we can do, we can find better systems that works better. Right. So we are going to witness a different world order. So whatever career opportunities that you see right now, whatever things that professional business opportunities that you see right now, it is going to change. So AI is going to help people to build billion-dollar companies, one-person billion-dollar companies sitting at home. So this is the kind of opportunity that AI is going to bring up. So in the terms of scientific research, if this is going to develop in a better way using AI, if it is used in an ethical manner, what is going to happen? Everybody gets an opportunity to be somebody who can contribute to the research field and help humanity to solve the problems that they face. That's actually where we train our students to be researchers at a very early age, because we always tell them there is no meaning in studying everything for the sake of getting a certificate or a job. Be somebody who can research and find out new solutions. Be somebody who think in an entrepreneurial manner and solve the problem the real world is facing. So this is another area what AI is going to solve, and genomics and bioinformatics. And this is going to help humanity in large, because if some kind of pandemic or genetic disease is going to happen, we can actually go into scientific research wherein we can research about genomics, because we know very little about the DNA. So the quantum computer and artificial intelligence is going to take lesser time to understand about the DNA and about the genomics and other informations. And this is also going to help us to take better decisions too. So this is going to not only going to help to diagnose the problem, but also come up with greater solutions and take greater decisions to move forward. So AI is going to help in that field. But this is ethics is another thing, because if it falls in the bad hands, what is going to happen? They are going to use it to eradicate a particular community or to eradicate a particular culture. Okay, so that shouldn't happen, but that we can solve only by bringing human values among the new generation. And that is what I think that is getting better. Each and every year, humanity is the kind of human thought that we are experiencing is getting better. It's not draining down as we always claim. The reality is different, because the society has become much more democratic, and the society has become much more human in the recent years. Right. So that is one area. And another one is regarding the environmental sustainability and climate action, because this is something related to the UN SDGs, because we were actually struggling with a lot of problem. Though we claim that the scientific advancements that we made in the recent years has solved a lot of problem, it has actually brought out a lot of other problems too. So we'll have to solve a lot of sustainability related issues and the climate related issues, because we are going to face a lot of challenges in that particular field, because we are not able to predict about the floods, and we are not able to predict about the cloud-based and other stuffs. But if AI is going to develop in the pace that we are experiencing right now, we can actually take greater decisions, not only in agriculture, but we can actually take greater decisions in climate actions. In terms of UN Sustainable Development Goals, we can come up with great solutions using artificial intelligence. So this is one area that we can use artificial intelligence in a better way, and in wildlife conservations too, because whatever we have seen right now, or whatever we have experienced right now, is just a trailer, and we are actually going to witness the real movie, and we are going to get to know about new species and new communities soon. So that is what we expect with the development of artificial intelligence, and with the coming up of with the researchers that come up with new materials and new processes to solve the problem. We will also be able to solve the waste management problem, because these are bigger problems that as the humanity advances with technology and different like advancements happens, what happens? We face a lot of new problems and challenges. So we can easily solve that with using the human creativity and artificial intelligence. So not only artificial, I'm not just claiming that artificial intelligence and robotics is going to solve the whole the problem, but a human being with great creativity using AI tools, they are going to be superhumans. So those superhumans are going to solve the problems of the real world. So you can think about other sectors. This is just I'm just sharing information about whatever I know, and I am somebody who is actually researching about the changes that need to be done in education sector. But there are different sectors. Each and every sector is going to be affected, because each and every sector has got a problem. So people always say that if we can't, if every job is the job of a doctor, the doctor is getting automated, the job of a teacher is getting automated, the job of a driver is getting automated. So what is going to happen to human beings? So nothing is going to happen. We are going to get new opportunities, because these were the things that should not have been done by us. We claim that the software should be developed by human beings, but this is something that we should not spend our time on. If artificial intelligence can do it in a better way, leave it to AI, take the next turn, take the next step in our growth. So that's where the real solution comes into place. That's where we got a great solution in education, because we thought of about dumping all the traditional conventional system, go by a new system, because it was our need to build a new system. So we found out amazing solutions, and we are not the only one behind this. There are a lot of people, researchers behind this. And believe me, these researchers are not alone, will not solve this educational problem. Everyone need to join hands. The traditional educational systems, the universities, the government, everyone should join hands to solve this problem of education, because that is one area that needs a great solution. Just bringing in an AI tutor or a robotic teacher or teaching STEM curriculum in your subjects is not going to solve the problem. It should be a complete solution, a solution that is going to work, or that is going to grow along with the advancements in artificial intelligence and technologies. That is going to solve the problem. It is a complete change. It is not an incremental change that is going to solve the problem. So let's discuss about the opportunities. Just set aside all the panics or all the kind of doubts we have. It is great to have doubts. It's great to question things, because that's how new systems get built, right? So don't panic. Don't panic about losing your jobs. Don't panic about artificial intelligence replacing you in workplace. Don't panic about artificial intelligence doing unethical things. Just be someone who use artificial intelligence in a better way, and be someone who can scale up, who can take up greater roles that artificial intelligence can't do. So that's where we become superhumans. Thank you very much. So the floor is open for questions, if any. So I'm ready to take the questions. So thank you very much for listening to me for the last 90 minutes. Thank you.
This is the time of question and answer session. So if the participants have any questions, please. Okay, so with that, on behalf of KMEA Engineering College and Computer Science Department, I thank Mr. Shihabuddin for the wonderful session, and it's a general thing, and what is happening in the era of AI and what is happening in the global scenario that he explained in a different way. So I hope the participant also get some information regarding all these, how AI is coming in different areas, and what are the things happening nowadays with this AI. So it's like eye-opening to all fields such as engineers or doctors. Anywhere these AI is available, it's everywhere. So everyone is talking about this technology only nowadays. Most of the people, I say most of the people. So this is one of the wonderful session, and once again on behalf of all the participants and all the faculty members of Computer Science Engineering KMEA College, I sincerely thank to Mr. Shihabuddin. Thank you for the wonderful session. Have a nice day.
Thank you very much.
So